Hello there and welcome. Tonight I want to take you somewhere special, somewhere far beyond the gentle glow of your bedside lamp, beyond the soft sounds of the night outside your window, beyond even the furthest reaches of what your eyes could see on the clearest night. I want to take you on a journey through a question that might seem impossible at first, perhaps even a little strange, but one that holds within it a kind of cosmic poetry that I think you'll find surprisingly soothing as you drift towards sleep. This isn't a journey that requires you to move or even to keep your eyes open. All you need to do is breathe, listen, and let your imagination float alongside mine as we explore one of the most intriguing questions I've ever encountered about our universe. Before we begin this gentle voyage together, I wonder where you might be listening from right now. Are you tucked into bed in a bustling city where the lights never quite go out, creating that soft orange glow against your curtains? Or perhaps you're in a quiet suburban room where the only sounds are the occasional car passing by and the whisper of wind through trees. Maybe you're somewhere rural, where the darkness is deep and complete, and the stars, if you were to peek outside, would be scattered across the sky like diamonds on black velvet. Whatever corner of our beautiful planet you're resting in tonight, whatever time zone cradles you at this moment, whether it's late evening, the deep middle of the night, or those quiet pre-dawn hours when the world feels most still, you're part of something much larger, something that connects us all through space and time in ways we're only beginning to understand. If you're finding comfort in these words, if this journey we're about to take together feels like something you'd like to return to, perhaps consider leaving a gentle like or subscribing so you can find your way back whenever you need, a peaceful escape into cosmic wonder. These small gestures help our quiet corner of contemplation reach others who might also be seeking this same sense of peaceful curiosity. But for now, let all of that fade into the background. Let the notifications quiet, let the day's demands dissolve, and let yourself simply be here, present in this moment as we begin to explore something truly extraordinary. The question I want to share with you tonight is this: what if the universe had a delete button? Not a dramatic, catastrophic button that would end everything in some frightening way. No, nothing like that at all. Instead, imagine something far more subtle, far more mysterious, perhaps even beautiful in its implications. Imagine a cosmic mechanism hidden somewhere in the fabric of reality itself that could gently erase things, moments, perhaps even entire chapters of cosmic history, as softly as you might delete a word from a sentence you're writing, or remove a photo from your phone that didn't quite capture the moment the way you remembered it. I know this might sound impossible at first. After all, we've been taught that matter and energy cannot be created or destroyed, only transformed from one form to another. We've learned that the universe operates according to consistent laws, that cause leads to effect in an unbroken chain stretching back to the very beginning of time itself. And yet, as we'll discover together tonight, the universe is far stranger, far more mysterious than our everyday experience suggests. There are phenomena in the cosmos that already behave in ways that seem almost like deletion, processes that make things disappear or transform so completely that their original form becomes impossible to recover. Think about your own experience for a moment. You've deleted things before, haven't you? Perhaps an email you decided not to send, a photograph that didn't turn out quite right, a document you no longer needed. When you press that delete button on your device, where does that information go? In one sense, it simply ceases to exist in its previous form. The patterns of ones and zeros that made up that file are overwritten, scattered, made available for new information to take their place. But in another sense, traces often remain, ghost images in the memory of the machine, fragments that a skilled technician might still be able to recover. The question of deletion, even in our simple, everyday devices, is more complex than it first appears. Now let's expand that thought to the scale of the universe itself. The cosmos, as far as we can tell, is approximately 13.8 billion years old. In all that time, countless stars have been born, have lived out their stellar lives, and have died. Entire galaxies have collided and merged. Countless particles have danced their quantum dances, appearing and disappearing in the vacuum of space. If the universe truly keeps a perfect record of everything that has ever happened, if every event, every particle interaction, every moment is somehow preserved in the fabric of reality, then the amount of information the universe would need to store would be truly staggering, perhaps infinite. But what if it doesn't? What if, hidden in the deep mechanics of reality, there exists something like a delete function, a way for the universe to selectively forget, to erase certain things while keeping others? This wouldn't be a violent or destructive process, but rather something as natural and gentle as the way your own mind lets go of most of the sensory information it receives every second, keeping only what seems important, letting the rest fade away into the background static of existence. As you lie there, perhaps you can feel your own body's gentle rhythm, the rise and fall of your chest as you breathe, the soft pulse of your heartbeat. These rhythms connect you to the larger rhythms of the universe, the oscillations of atoms, the orbits of planets, the rotation of galaxies. You're not separate from the cosmos, but are woven into its very fabric, made of star stuff, as Carl Sagan so beautifully put it, atoms forged in the hearts of ancient stars that exploded billions of years ago, scattering their enriched essence across space to eventually become part of planets, and ultimately part of you. This connection means that if the universe does have something like a delete button, you're not outside looking in at this cosmic mystery, you're part of it, swimming in it, made of it. Every atom in your body has existed since shortly after the Big Bang, transformed countless times but never truly created or destroyed. Or has it? What if, in ways we don't yet understand, the universe has been editing itself all along, and we living within this edited reality simply cannot perceive the changes because we're part of the story being revised? Consider the vastness of space for a moment. The observable universe, the part we can see with our most powerful telescopes, spans approximately 93 billion light-years in diameter. Within this incomprehensible volume, there are estimated to be over 2 trillion galaxies, each containing hundreds of billions of stars. Many of these stars have planets, and on at least one of those planets, as far as we know, life emerged and evolved to the point where it could contemplate its own existence and the nature of the universe itself. That's you, that's us, these unlikely arrangements of atoms that can wonder about deletion buttons and cosmic mysteries. The light from the most distant galaxies we can see has been travelling toward us for over 13 billion years. When we look at these ancient galaxies, we're not seeing them as they are now, but as they were when the universe was young, less than 1 billion years old. In a very real sense, we're looking back in time, seeing the universe's baby pictures preserved in light that has been crossing the cosmic void while entire species evolved and went extinct on Earth, while continents drifted and mountains rose and wore away, while our ancestors learned to use tools to speak, to write, to build telescopes that could capture this ancient light. But here's where our question becomes even more intriguing. If the universe had a delete button, and if something in the distant past had been erased, would we see evidence of that deletion in this ancient light? Or would reality restructure itself so seamlessly that the deletion would be undetectable, like a sentence that reads perfectly, even though a word has been removed, the grammar adjusting itself automatically to maintain coherence? Scientists have found some puzzling things in their observations of the cosmos that might, just might, hint at something like cosmic editing. There are vast voids in space, regions where we would expect to find galaxies but instead find almost nothing, as if patches of the universe have been gently erased, leaving only the faintest traces of their former existence. There are cosmic flows and movements that don't quite match what our models predict, as if invisible hands have been rearranging the cosmic furniture when we weren't looking. And perhaps most mysteriously, there's the issue of dark matter and dark energy, substances we can't see or directly detect but which seem to make up 95% of the universe, as if most of reality has been written in invisible ink, or perhaps partially deleted but still somehow affecting what remains. Now, I want you to imagine something with me. Picture yourself floating high above the Earth, so high that you can see the gentle curve of our planet against the darkness of space. Below you, the blue and white marble of the Earth turns slowly, clouds swirling in their ancient patterns, continents visible as brown and green patches beneath the atmospheric veil. From up here, all of human history, every life that has ever been lived, every story ever told, has happened on that one small sphere. Every deletion, every forgetting, every loss and every discovery, all contained within that thin shell of air and water and rock. Now, let your perspective expand further. The Earth shrinks to a point of a light, one planet among others orbiting our familiar sun. then the sun itself becomes just one star among billions in the spiral arms of the Milky Way galaxy. The galaxy becomes one among countless others, scattered like seeds across the dark field of space. And somewhere in all of this vastness, according to our thought experiment, there might exist a kind of cosmic delete button, a mechanism by which the universe can edit itself. But what would such a mechanism look like? How would it operate? Perhaps it wouldn't be a button at all in any conventional sense, but rather a fundamental property of space-time itself, as basic to the universe as gravity or electromagnetism. Maybe deletion happens constantly at scales too small for us to perceive. Quantum fluctuations erasing and rewriting reality billions of times per second, but averaging out to the stable world we experience. Or perhaps it operates on cosmic timescales, so slow that a single deletion event might take millions of years to complete, imperceptible to beings like us who live for only a cosmic eye blink. Think about black holes for a moment, those regions of space where gravity has become so strong that nothing, not even light, can escape once it crosses the event horizon. For decades, scientists believed that anything falling into a black hole was effectively deleted from the universe, crushed down to a point of infinite density and removed from the cosmic story. But then Stephen Hawking showed that black holes aren't perfectly black. They emit a faint radiation, now called Hawking radiation, and slowly evaporate over vast periods of time. This discovery led to what's known as the information paradox, the question of whether information that falls into a black hole is truly deleted or somehow preserved in the radiation that eventually escapes. This paradox has profound implications for our delete button question. If even black holes, the most extreme gravitational objects in the universe, cannot truly delete information, then perhaps true deletion is impossible in our cosmos. Or perhaps black holes are actually the universe's delete buttons, and the information paradox exists precisely because we're trying to understand a deletion mechanism from inside the system being edited. It would be like a character in a novel trying to understand what happens to deleted paragraphs. They simply wouldn't have access to that level of reality. As you continue to breathe slowly and deeply, letting these ideas wash over you like gentle waves, consider that deletion might not be about destruction at all. In our digital world, when we delete something, we often think of it as gone forever, but in reality, deletion is usually just a form of transformation. The physical bits on a hard drive don't disappear, they're simply marked as available to be overwritten. The energy that encoded the information doesn't vanish, it just gets reorganized into new patterns. Perhaps the universe's delete button, if it exists, works the same way. Nothing is truly lost, just transformed so thoroughly that its previous form becomes unrecoverable by any means available to us. The stars that died billions of years ago weren't deleted. They were transformed into nebulae, into new stars, into planets, into you. Their light still travels through space, carrying information about what they were, even though the stars themselves are long gone. In this view, the universe's delete button might be more like a transformation button, a mechanism for change rather than annihilation. Let's bring this idea closer to home, closer to your immediate experience. Your own brain performs something like deletion every moment of your existence. Right now, your sensory organs are detecting millions of bits of information, the feeling of the fabric against your skin, the subtle sounds of your environment, the play of light and shadow even through your closed eyelids. But your conscious mind is aware of only a tiny fraction of this information. The rest is filtered out, deleted from your conscious experience, though perhaps not from your unconscious processing. And what about memories? You've forgotten far more than you remember. The vast majority of your experiences, thoughts, and sensations have been deleted from your accessible memory. What did you have for lunch on a random Tuesday 5 years ago? What was the first thing you thought when you woke up last month? These moments existed. They were real. You experienced them fully at the time, but now they're gone, deleted from your personal story, though their effects might still ripple through your life in ways you don't consciously recognize. Sleep itself, the state you're gradually approaching as you listen to these words, is a kind of gentle deletion process. During sleep, your brain consolidates memories, keeping some and letting others fade away. It clears out metabolic waste products that accumulated during the day, essentially deleting the cellular debris of consciousness. Dreams might be the brain's way of processing and deleting unnecessary information. playing through scenarios and experiences before letting them go, keeping only what seems important for your survival and well-being. In this way, you're already intimately familiar with deletion as a natural, necessary, and even beautiful process. Without the ability to forget, to let go, to delete the unnecessary, you would be overwhelmed by the sheer volume of information your brain processes. The universe, if it has a delete button, might face the same challenge on a cosmic scale. After 13.8 billion years of existence, the amount of information encoding every particle interaction, every quantum event, every moment of cosmic history would be truly infinite. Perhaps deletion, or something like it, is necessary for the universe to continue functioning, to make room for new experiences, new configurations, new possibilities. As we continue this journey together, floating through these ideas like dust motes in a sunbeam, I want to acknowledge something important. These are speculations, thought experiments, gentle wanderings through the possible rather than statements of confirmed fact. Science has not discovered a literal delete button in the universe, and perhaps it never will. But the joy of questions like these isn't in finding definitive answers, it's in the journey of exploration itself, in the way such questions can shift our perspective and help us see the familiar world with new eyes. The universe, as we currently understand it, operates according to conservation laws. Energy is conserved, momentum is conserved, and according to our best theories, information itself is conserved, even if it becomes scrambled beyond recognition. But these laws are based on our observations of the universe as it appears to us, from our limited perspective as tiny beings on a small planet orbiting an ordinary star. What if there are aspects of reality that we simply cannot perceive? Dimensions of existence where different rules apply, where deletion is not only possible but commonplace. String theory, one of the attempts to unify quantum mechanics and general relativity, suggests that reality might have many more dimensions than the 3 spatial dimensions and 1 time dimension that we experience. These extra dimensions, if they exist, are thought to be curled up so small that we cannot detect them directly. But what if deletion happens in these hidden dimensions? What if when something appears to vanish from our 4-dimensional spacetime, it's actually just been moved to a dimension we cannot access? Like moving a file to a hidden folder on a computer. Or consider the many worlds interpretation of quantum mechanics, which suggests that every quantum event causes the universe to branch into multiple parallel realities, each representing a different possible outcome. In this view, nothing is ever truly deleted. Every possibility is realized somewhere in the vast multiverse. But from the perspective of any individual branch, any single timeline, all the other possibilities might as well have been deleted, erased from that particular version of history. The gentle hum of existence continues around you as you contemplate these ideas. Perhaps you can hear the faint sounds of the world outside, cars in the distance, wind through leaves, or maybe just the quiet settling of your home as it cools in the night. These sounds are vibrations in the air, patterns of pressure that your ears detect and your brain interprets. But between each sound is silence, a kind of deletion of vibration, a space where sound doesn't exist. Music, conversation, all the sounds you love depend on this interplay between sound and silence, between presence and absence, between existence and deletion. Light, too, depends on darkness to be meaningful. The stars are always shining, but we can only see them when the bright light of our local star, the sun, is deleted from our sky by the Earth's rotation. The beauty of a starry night depends entirely on the deletion of daylight, on the absence that allows the subtle presence of distant suns to be perceived. In this way, deletion and existence are not opposites but partners in the dance of reality, each giving meaning to the other. As we approach the deeper parts of our exploration, I want to return to that image of you floating above the Earth, but this time, let's go further. Let yourself drift away from our planet, past the moon with its ancient cratered face, past Mars with its rusty red deserts, past the giant Jupiter with its swirling storms, past Saturn with its magnificent rings. Keep going, past the ice giants Uranus and Neptune, past the Kuiper Belt where Pluto and its companions circle in the darkness, past the heliopause where the solar wind meets the interstellar medium. Now you're in true interstellar space, the vast emptiness between stars. Here, in this profound darkness, you might think you've found a place where things have been deleted, where nothing exists. But even here, in what seems like perfect emptiness, space is not truly empty. Virtual particles pop into existence and annihilate each other constantly, a quantum foam of creation and deletion happening at scales trillions of times smaller than an atom. Cosmic rays zip through the darkness, carrying information from distant catastrophes. Gravitational waves ripple through space-time itself, distortions in the fabric of reality caused by colliding black holes billions of light years away. Even in the deepest void, deletion is not complete. Traces remain, influences persist, information continues to flow. This might be telling us something profound about the nature of our hypothetical cosmic delete button. Perhaps true, absolute deletion is impossible. Perhaps the best the universe can do is to hide information, to scramble it, to spread it out so thin that it becomes practically irretrievable, but never truly gone. Think about the cosmic microwave background radiation, that faint glow that fills all of space, the echo of the Big Bang itself. This radiation has been travelling through space for 13.8 billion years, carrying information about the universe when it was only 380,000 years old. If the universe had a perfect delete button, surely this ancient information would have been erased by now, overwritten by all the events that have happened since. But it persists, stretched and cooled by the expansion of space, but still there, still detectable, still telling its ancient story to anyone with the right instruments to listen. We've sent our own messages into this cosmic ocean. The radio signals from our broadcasts have been spreading outward from Earth at the speed of light for about a century now. Our earliest radio transmissions have now reached stars over 100 light-years away. If there are beings on planets orbiting those stars with sensitive enough equipment, they could be listening to our old radio shows, our early television broadcasts, our first tentative attempts at radar. These signals are incredibly faint by the time they reach such distances, but they're not deleted. They continue to expand outward in an ever-growing sphere, carrying information about Earth's technological civilization into the cosmos. The Voyager spacecraft, launched in 1977, carry golden records containing sounds and images from Earth, messages for any intelligent beings that might find them in the distant future. These spacecraft are now in interstellar space, heading out into the galaxy at speeds that will take them tens of thousands of years to reach even the nearest stars. But they will persist, these tiny ambassadors of Earth, carrying their messages through the cosmic dark for millions, perhaps billions of years. Unless, of course, they encounter our hypothetical delete button, some cosmic mechanism that could erase them from existence. But would we ever know if they were deleted? If the universe's delete button worked perfectly, erasing not just objects, but all traces of their existence, all memories, all records, all consequences of their having existed, then from our perspective, it would be as if they had never been launched at all. Our history would seamlessly adjust itself, and we would live in a world where the Voyager missions never happened, with no awareness that anything had changed. This brings us to a fascinating paradox. If the universe has a perfect delete button, one that erases things so completely that no trace remains, not even in our memories or records, then it could be operating constantly, deleting things left and right, and we would have no way of knowing. The universe we experience could be full of holes, gaps, where deleted things once existed, but these gaps would be invisible to us because our memories and perceptions would adjust to maintain consistency. Perhaps you've experienced something like this in your own life. Have you ever been absolutely certain you remembered something one way, only to find evidence that it happened differently? Maybe you were sure you put your keys in one place, but found them somewhere else entirely. Maybe you remembered a conversation going one way, but the other person involved remembers it completely differently. These could be simple failures of memory, of course, but what if some of them are glimpses of the universe's delete button at work? Moments where reality has been edited and our memories haven't quite caught up? As you lie there, drifting deeper into relaxation, your breathing becoming slower and more regular, your muscles releasing their tension, you're performing your own gentle deletions. The concerns of the day are being erased from your immediate awareness. The to-do lists, the worries, the plans for tomorrow, all of these are being temporarily deleted from your conscious mind, though they'll likely return when you wake. This nightly deletion is necessary for your well-being, a clearing of the mental cache that allows you to process, consolidate, and prepare for new experiences. The universe might need something similar. After billions of years of cosmic evolution, countless stellar generations, innumerable quantum interactions, the accumulated information might need to be periodically cleaned up, organized, simplified. Black holes might serve this function, swallowing information and scrambling it beyond recognition. The expansion of the universe might be another form of deletion, stretching information out until it becomes too diffuse to be meaningful. Entropy itself, the tendency toward disorder, might be the universe's way of gradually erasing the sharp distinctions and clear information that characterized its youth. But let's return to our central question with a slightly different perspective. What if the universe doesn't have a single delete button, but many different kinds of deletion mechanisms, each operating at different scales and in different ways? At the quantum scale, virtual particles delete themselves almost as soon as they appear. At the atomic scale, radioactive decay deletes unstable nuclei, transforming them into different elements. At the stellar scale, supernovae delete massive stars while creating and dispersing new elements. At the galactic scale, collisions delete the original structures of galaxies while creating new ones. Each of these processes could be seen as a form of cosmic editing, ways the universe revises itself, updates its configuration, makes room for new possibilities. And perhaps, at scales we haven't yet discovered, or in dimensions we cannot perceive, there are other deletion mechanisms at work, quietly editing reality in ways we're only beginning to suspect. Consider dark energy, that mysterious force that appears to be accelerating the expansion of the universe. We don't know what dark energy is, but we can observe its effects. It's causing galaxies to move apart from each other at an ever-increasing rate. Eventually, if this continues, galaxies outside our local group will be deleted from our observable universe, pushed beyond the cosmic horizon where their light can never reach us again. They won't be destroyed, but from our perspective, they'll be effectively erased, deleted from our cosmic story. This is already happening, in fact. There are galaxies whose light we can see now that future astronomers will never be able to observe. The accelerating expansion of space is gradually deleting the distant universe from our view, leaving us in an island of visibility that grows lonelier with each passing eon. Billions of years from now, if intelligent beings exist in our galaxy, they might look out and see only darkness beyond our local group, with no evidence that the universe was ever filled with billions of other galaxies. The cosmic delete button, in this case, isn't destroying anything, just hiding it beyond an ever-expanding veil. As we near the end of this first chapter of our journey, I want to bring your attention back to your immediate surroundings, to the gentle cocoon of your resting place. Feel the weight of your body supported by your bed, the soft embrace of your blankets, the cool air on any exposed skin. You are here, now, in this moment, even as we've travelled together through vast scales of space and time. You are both the observer and the observed, the questioner and part of the question itself. The idea of a cosmic delete button might seem abstract, distant from your daily life, but it connects to something deep in human experience. We all know what it's like to wish we could delete something, a mistake, a painful memory, an embarrassing moment. We all know the relief of letting go, of moving on, of allowing the past to fade. And we all know the fear of being forgotten, of having our existence erased from memory, of deletion in its most personal form. But perhaps the universe's delete button, if it exists, isn't something to fear. Perhaps it's part of what makes existence beautiful, meaningful, precious. If nothing could ever be deleted, if every moment persisted forever in perfect clarity, would new moments have the same value? Would change be possible? Would growth, evolution, and creativity exist in a universe where nothing could ever be erased or transformed? The gentle art of deletion might be essential to the cosmic story. The spaces between the notes that make the music possible, the darkness that gives meaning to the light, the forgetting that makes remembering precious. As you drift towards sleep, you're participating in this cosmic rhythm, letting go of today to make room for tomorrow, deleting the immediate past to create space for dreams and restoration. In our next chapter, we'll explore how the universe might store information, how it remembers, and what it might mean for something to be truly erased from cosmic memory. We'll look at the ways information is encoded in everything from light to gravity, from atoms to galaxies, and consider whether true deletion is even possible in a universe that seems to remember everything in one form or another. But for now, let yourself rest in the mystery, in the question itself. What if the universe had a delete button? What would that mean for existence, for meaning, for the nature of reality itself? These are questions without easy answers, perhaps without any answers at all, but they're questions that can carry us into profound contemplation, into a state of wonder that borders on the meditative, into the kind of deep thinking that naturally leads to deep rest. The universe, in ways both obvious and subtle, never forgets. As you continue to rest there, perhaps settling even deeper into comfort, your breathing finding its own quiet rhythm, we're going to explore one of the most profound realizations of modern physics. That information, in some form, appears to be indestructible. Every event, every interaction, every moment that has ever occurred has left its mark on the fabric of reality, creating what we might call the cosmic memory, a vast archive of everything that has ever been. Think about the light entering your room right now, even if your eyes are closed, even if the room seems dark. That light has a history, a story to tell. If it's starlight filtering through your window, it might have travelled for years, decades, centuries, or even millennia to reach you. The light from the star Sirius, the brightest star in our night sky, takes about 8.6 years to reach Earth. When you see Sirius, you're not seeing it as it is now, but as it was 8.6 years ago. The star could have exploded 5 years ago, and we wouldn't know for another 3.5 years. In this way, light is a form of cosmic memory, carrying information about the past into the present, preserving moments that have long since passed in the reference frame of their origin. But light carries more than just the fact of a star's existence. Encoded in that light is information about the star's temperature, its chemical composition, its motion through space, its rotation rate, even the presence of any planets that might orbit it. When astronomers spread starlight out into a spectrum, they can read these details like a cosmic fingerprint unique to each star. The dark lines in a stellar spectrum, called absorption lines, tell us exactly which elements are present in the star's atmosphere. The slight shift of these lines toward the red or blue end of the spectrum tells us whether the star is moving toward or away from us. The subtle dimming that occurs when a planet passes in front of the star reveals worlds we could never see directly. Every atom in the universe is constantly writing its autobiography, in light. When an electron in an atom jumps from one energy level to another, it emits or absorbs a photon with a very specific energy, a specific color of light. This is why neon signs glow with their characteristic colors, why sodium streetlights cast that distinctive yellow light, why the aurora borealis paints the sky in greens and reds. Each element has its own signature, its own way of interacting with light, and this signature is preserved in every photon that interacts with it. Consider what this means for our question about cosmic deletion. If the universe truly had a delete button, it would need to somehow erase not just objects, but all the light they've ever emitted, all the photons carrying information about them that are already spreading through space at 299,792,458 meters per second. A star that was deleted 1,000 years ago would still appear to exist for observers 1,000 light years away. Its light, its information, would continue to propagate through space like ripples on a pond long after the stone that caused them had sunk to the bottom. But light is just one way the universe remembers. Gravitational waves, those ripples in space-time itself predicted by Einstein, and finally detected by the LIGO and Virgo observatories in 2015, carry information about cosmic catastrophes across billions of light years. When two black holes spiral into each other and merge, they send out gravitational waves that stretch and squeeze space itself as they pass. These waves are incredibly weak by the time they reach Earth, changing the distance between objects by less than the width of a proton, but our instruments can detect them, and encoded in their pattern is precise information about the masses of the black holes, their distance from us, and the way they danced around each other in their final moments before merging. These gravitational waves, like light, continue to propagate through space long after the event that created them. The merger might have happened 1 billion years ago in a galaxy far away, but the waves are just reaching us now, carrying that billion-year-old information perfectly preserved in the subtle distortions of space-time. If one of those black holes had somehow been deleted before the merger, the gravitational waves would tell a different story, or perhaps no story at all. The universe's memory, encoded in these waves, would be altered. Let's think about memory in a more familiar context for a moment. Your own memories are encoded in the connections between neurons in your brain, in the strength of synapses, in the patterns of chemical and electrical activity that somehow give rise to your subjective experience of remembering. When you remember something, you're not accessing a perfect recording but reconstructing an experience from these patterns. Each time you remember something, you slightly change the memory itself, updating it with your current perspective, your current emotional state, your current understanding of the world. The universe's memory might work in a similar way, not as a perfect unchanging record, but as a dynamic system where information is constantly being processed, transformed and updated. The cosmic microwave background radiation, that ancient light from when the universe was only 380,000 years old, has been stretched and cooled by the expansion of space, its information transformed but not destroyed. The pattern of tiny temperature fluctuations in this radiation tells us about the distribution of matter in the early universe, the seeds that would grow into galaxies and clusters of galaxies. But this pattern has been modified by its journey through space, influenced by the gravitational fields it has passed through, a phenomenon called gravitational lensing that actually adds information about the matter between us and the early universe. Scientists have created incredibly detailed maps of the cosmic microwave background using satellites like COBE, WMAP, and most recently Planck. These maps show temperature variations of just a few parts in 100,000, tiny differences that represent the quantum fluctuations in the very early universe, magnified by cosmic inflation to become the large-scale structure we see today. In a very real sense, we're looking at the universe's baby picture, its earliest memory that we can access, preserved in this faint radiation that fills all of space. But what about the memories from before the cosmic microwave background? The universe was opaque to light for its first 380,000 years. A hot, dense soup of particles where photons couldn't travel far before being absorbed and re-emitted. Any light-based information from this era has been effectively erased, scrambled beyond recovery. Yet even this early period left other forms of memory. The abundance of light elements like hydrogen and helium tells us about the conditions in the first few minutes after the Big Bang when nuclear fusion could occur throughout the universe. The tiny variations in the cosmic microwave background preserve information about the quantum fluctuations during inflation, those first fraction of a second when the universe expanded faster than the speed of light. Some physicists have proposed that information might be the most fundamental aspect of reality, more basic than matter or energy. In this view, particles are not tiny balls of stuff, but rather stable patterns of information, knots in the fabric of quantum fields. The physicist John Wheeler coined the phrase "it from bit" to capture this idea, suggesting that all physical entities are information theoretic in origin. If this is true, then asking whether the universe has a delete button is really asking whether the universe can destroy information, whether it can truly erase parts of itself at the most fundamental level. The question of information preservation becomes particularly acute when we consider black holes, those regions of space where gravity is so strong that nothing can escape. For decades, physicists believed that information falling into a black hole was lost forever, deleted from the universe. But this created a paradox when combined with quantum mechanics, which says that information must be preserved. Stephen Hawking showed that black holes emit radiation and slowly evaporate. But this Hawking radiation seemed to be completely random, containing no information about what fell into the black hole. Where did the information go? This information paradox has been one of the most challenging problems in theoretical physics for the past 40 years. Various solutions have been proposed. Some physicists suggest that information is encoded on the two-dimensional surface of the black hole, the event horizon, rather than in its three-dimensional volume, an idea called the holographic principle. Others propose that information slowly leaks out in subtle correlations in the Hawking radiation, too subtle for us to detect but preserved nonetheless. Still others suggest that information might escape through microscopic wormholes, or be preserved in baby universes that branch off from our own. Recent theoretical work has suggested that black holes might not delete information, but rather scramble it in the most efficient way possible. The information that falls in is still there, but it's been mixed and processed so thoroughly that it would take longer than the age of the universe to decode it. It's like taking a library of books, shredding them into individual letters, mixing all the letters together, and then trying to reconstruct the original books. The information is still there, every letter is preserved, but it's been scrambled beyond practical recovery. This brings us to an important distinction: deletion versus scrambling. When you delete a file on your computer, the information often isn't immediately destroyed. Instead, the space it occupied is marked as available for new data. Until that space is overwritten, the information can often be recovered with the right tools. Even after being overwritten, traces might remain in the form of magnetic variations on the hard drive or electrical charges in solid-state memory. True deletion, complete erasure with no possibility of recovery, is surprisingly difficult to achieve even with our simple electronic devices. The universe might face the same challenge on a cosmic scale. True deletion might be impossible, with the best the universe can do being to scramble information so thoroughly that it becomes practically irrecoverable. This scrambling happens naturally through entropy, the tendency of systems to evolve toward disorder. When you stir milk into coffee, the initial pattern of white milk and black coffee is scrambled into a uniform brown. The information about the original pattern is still there in principle, encoded in the exact positions and velocities of all the molecules, but it's been scrambled beyond any practical hope of recovery. Entropy always increases in isolated systems, according to the second law of thermodynamics. This means that information naturally becomes more scrambled over time. A sandcastle on the beach contains information in its structured shape, but wind and waves will gradually scramble this information, spreading the sand grains randomly across the beach. The universe as a whole is evolving toward maximum entropy, a state physicists call heat death, where all information has been scrambled uniformly throughout space. But even at maximum entropy, information wouldn't be deleted, just maximally scrambled. Every particle would still be somewhere, moving in some direction, carrying the scrambled information of everything that ever happened. It would be like a cosmic library, where all the books have been reduced to a uniform soup of letters, unreadable, but not truly erased. This might be the universe's ultimate fate, not deletion, but the ultimate scrambling, where all structure, all patterns, all memories have been dispersed into random noise. Yet the universe has mechanisms that fight against this scrambling, at least temporarily. Gravity pulls matter together, creating structure from randomness. Stars form from diffuse gas clouds, creating centers of order where nuclear fusion builds complex elements from simple hydrogen. Life itself is a process that creates local decreases in entropy, building complex information-rich structures like DNA, brains, and civilizations. These are islands of memory in an ocean of forgetting, temporary repositories where information is concentrated and preserved. Your own brain is one of these islands of concentrated information. The human brain contains about 86 billion neurons, each connected to thousands of others through synapses. The pattern of these connections, the strength of each synapse, the state of each neuron, all of this represents information. Some scientists estimate that the human brain can store about 2.5 petabytes of information, equivalent to about 3 million hours of television shows. But this is just the information we can consciously access. The brain also stores vast amounts of unconscious information: how to regulate heartbeat and breathing, how to coordinate muscles for movement, how to process sensory input, how to maintain balance and posture. As you lie there, your brain is busy processing and consolidating memories from the day, deciding what to keep and what to let fade. During different stages of sleep, different types of memories are processed. Slow-wave sleep seems particularly important for consolidating declarative memories, facts and events you can consciously recall. REM sleep, when most dreams occur, might be important for emotional memories and creative problem-solving. In a sense, sleep is when your brain does its filing, organizing the day's information, strengthening important memories, and allowing unimportant ones to fade. This process of memory consolidation involves physical changes in your brain. Synapses are strengthened or weakened, new connections are formed, proteins are synthesized to stabilize memory traces. When you wake tomorrow, your brain will be physically different than it is right now, restructured by the process of remembering and forgetting. Some of today's experiences will be preserved, encoded in lasting changes to your neural architecture. Others will be allowed to fade, their information dispersed and overwritten by new experiences. The universe might have its own version of sleep periods or processes where cosmic information is consolidated and organized. The formation of structure in the universe, from the first galaxies to the latest generation of stars, could be seen as a kind of memory consolidation, where diffuse information is gathered and concentrated into lasting patterns. Black holes might serve as cosmic recycling centers, taking in old information, processing it, and eventually releasing it in a new form through Hawking radiation. Let's consider another way the universe preserves information, through the quantum vacuum itself. Empty space is not truly empty, but seethes with quantum fluctuations, virtual particles that appear and disappear in pairs, borrowing energy from the vacuum and paying it back so quickly that they don't violate conservation of energy. These fluctuations are influenced by everything around them, by nearby particles, fields, and forces. In principle, the pattern of vacuum fluctuations contains information about everything that influences them. This quantum foam, as it's sometimes called, might be the universe's ultimate backup system, preserving information in the most fundamental structure of space-time itself. Even if all matter and radiation were somehow deleted, the quantum vacuum would remember, its fluctuations forever altered by what once existed. This is highly speculative, far beyond what we can currently test or observe, but it suggests that true deletion might be impossible even in principle, that every event leaves an indelible mark on the fabric of reality itself. The Voyager spacecraft, which we mentioned earlier, carry golden records with sounds and images from Earth. These records are designed to last billions of years, their information encoded in physical grooves that could survive the harsh environment of interstellar space. But even if the records were somehow deleted, destroyed completely, their influence would persist. They've already affected the trajectories of dust particles they've passed, altered the magnetic fields they've travelled through, gravitationally influenced, however minutely, every object in their vicinity. These influences spread outward like ripples, carrying information about the Voyager spacecraft throughout the cosmos. This is a key insight. Information is not just stored in objects, but in relationships, in the ways things influence each other. The Moon remembers the Earth through the tidal locking that keeps one face always pointed toward us. The Earth remembers ancient asteroid impacts in the form of craters, some still visible, others long erased from the surface but preserved in the geological record, in layers of rock that tell the story of sudden catastrophe, followed by slow recovery. The solar system remembers its formation in the orbits of planets, all moving in the same direction in nearly the same plane, a fossil memory of the rotating disk of gas and dust from which they formed. Even abstract mathematical relationships might constitute a form of cosmic memory. The ratio of a circle's circumference to its diameter is pi, an irrational number whose decimal digits go on forever without repeating. Encoded in those infinite digits, some mathematicians suggest, is every possible finite sequence of numbers, including, if properly interpreted, every piece of information that could ever exist. The entire history of the universe, every thought ever thought, every word ever spoken, might be hidden somewhere in the infinite decimal expansion of pi. Of course, finding any specific piece of information would be impossible, like looking for one particular grain of sand on an infinite beach, but the information would be there, preserved in the abstract structure of mathematics itself. As we delve deeper into how the universe remembers, we encounter the concept of quantum entanglement, what Einstein famously called spooky action at a distance. When two particles become entangled, they remain connected in a way that transcends space. Measure the spin of one particle, and you instantly know the spin of its entangled partner, no matter how far apart they are. This connection preserves information about the particles' shared origin, their common past, even as they fly apart at near the speed of light. Entanglement might be another way the universe preserves information, creating a vast network of quantum correlations that remember how particles have interacted. Some physicists have proposed that the entire universe might be entangled, every particle connected to every other through chains of past interactions. In this view, the universe is not a collection of separate objects, but a single, unified quantum system, where information about any part is subtly encoded in the whole. This brings us to the holographic principle, one of the most mind-bending ideas in modern physics. According to this principle, all the information contained in a volume of space can be encoded on the boundary of that space, like a hologram where a two-dimensional surface contains all the information needed to reconstruct a three-dimensional image. If the holographic principle is correct, then the entire universe might be encoded on its boundary, wherever and whatever that might be. Every event, every particle, every piece of information in the cosmos might have a corresponding encoding on some distant surface, a cosmic backup that preserves everything, even if the interior were somehow deleted. The holographic principle emerged from studying black holes and the puzzle of where information goes when it falls past the event horizon. The surface area of a black hole's event horizon, not its volume, determines how much information it can contain. This was a shocking discovery because we normally think of information as being stored throughout a volume, like books throughout a library, not just on the library's walls. But for black holes, and perhaps for the universe as a whole, information might be fundamentally two-dimensional, with the three-dimensional world we experience being a kind of projection or emergence from this more fundamental encoding. Consider what this means for our cosmic delete button. If information is holographically encoded on the universe's boundary, then deleting something from the interior wouldn't truly erase it. The information would still exist on the boundary, like deleting a file from your computer but forgetting to empty the recycle bin. The universe might appear to have a delete button, but it would be more like a hide button, moving information from one place to another rather than truly destroying it. We can see something similar in our everyday experience with digital information. When you send a message and then delete it from your device, copies might exist on servers, in backups, in the recipient's device, in cached versions, in logs and metadata. True deletion in our interconnected digital world is nearly impossible. The universe, with its network of quantum entanglements, gravitational influences, and electromagnetic radiations, might face the same challenge on a cosmic scale. Every event is connected to every other through chains of cause and effect, making true isolation and true deletion practically impossible. The cosmic web, the largest structure in the universe, is itself a kind of memory. Galaxies not randomly distributed through space, but form a vast network of filaments and walls separated by enormous voids. This structure preserves information about the quantum fluctuations in the very early universe, magnified by billions of years of gravitational evolution. Computer simulations starting from slightly different initial conditions produce different cosmic webs, showing that the exact structure we observe encodes specific information about our universe's unique history. Dark matter, that mysterious substance that makes up about 27% of the universe's mass-energy content, might be another repository of cosmic memory. We can't see dark matter directly, but we can observe its gravitational effects on visible matter. The distribution of dark matter preserves information about the early universe, forming the scaffolding on which visible galaxies grew. Every galaxy sits in a halo of dark matter that remembers the gravitational history of that region of space, the mergers and interactions that built the galaxy we see today. Even the expansion of space itself is a form of memory. The current expansion rate, the Hubble constant, tells us about the universe's entire history of expansion. The acceleration of this expansion, discovered in 1998 and attributed to dark energy, adds another layer of information. By measuring the expansion rate at different times in cosmic history, using distant supernovae as standard candles, we can read the universe's expansion history like tree rings, each era leaving its mark on the overall pattern. The elements themselves are cosmic memories. Hydrogen, the simplest element, formed in the first few minutes after the Big Bang. Helium too formed in those early moments, along with trace amounts of lithium. But all the heavier elements, the carbon in your body, the oxygen you breathe, the iron in your blood, were forged in the nuclear furnaces of stars or in the violent explosions of supernova. Each atom of these elements carries the memory of stellar processes, of temperatures reaching millions or billions of degrees, of pressures that dwarf anything we can create on Earth. When astronomers analyze the light from distant galaxies, they can determine the abundance of different elements, reading the chemical history of that galaxy. Older galaxies have fewer heavy elements because fewer generations of stars have had time to create them. Younger regions of star formation are enriched with heavy elements from previous stellar generations. This chemical evolution is a form of cosmic memory, each generation of stars building on the ashes of the previous one, adding new information to the universe's chemical library. Your own body is a collection of these cosmic memories. The calcium in your bones might have been forged in a supernova explosion 5 billion years ago. The water in your cells contains hydrogen atoms that have existed since the universe was 3 minutes old. You are not separate from cosmic history, but are made of it, a temporary arrangement of ancient atoms that have been part of countless other configurations. interstellar gas clouds, previous generations of stars, perhaps other planets, possibly even other forms of life. As you breathe, you're exchanging atoms with your environment, taking in oxygen that might have been exhaled by a tree this morning, by a dinosaur millions of years ago, by the first photosynthetic bacteria billions of years ago. With each breath, you're participating in this vast circulation of atoms, this cosmic recycling system that preserves and transforms information across deep time. The atoms don't remember their history in any conscious sense, but their very existence, their isotopic ratios, their chemical bonds, all encode information about where they've been and what they've experienced. Let's think about fossils for a moment, those preserved remains of ancient life that tell us about Earth's biological history. A fossil is a kind of memory, information about a living creature encoded in stone. But fossils are rare. The vast majority of organisms that have ever lived left no fossils, no direct record of their existence. Yet they're not truly forgotten. Their influence persists in the descendants they left behind, in the evolutionary changes they contributed to, in the oxygen they produced or consumed, in the small ways they altered their environment. The universe might work the same way. Not everything leaves a fossil, a clear, preserved record, but everything leaves influences, subtle changes that ripple outward through space and time. Even if something could be deleted from one form of cosmic memory, these influences would persist in others. It's like trying to remove a person from history. You could destroy all photographs, all documents, all direct records, but you couldn't erase the ways they influenced others, the chains of cause and effect they set in motion, the subtle ways they changed the course of events. This interconnectedness suggests that the universe's memory is not localized but distributed, not stored in any one place but woven throughout the fabric of reality. Every particle, every field, every quantum of energy carries part of the cosmic memory, like a hologram where each piece contains information about the whole. This distributed storage makes the universe's memory incredibly robust. Even if large portions were somehow deleted, the remaining parts would still contain information about what was lost, encoded in the patterns and relationships that survive. As we approach the transition to our next exploration, consider the profound implications of this cosmic memory. If the universe truly remembers everything, if information is preserved even when it seems to be lost, then in a sense, nothing ever truly ends. The stars that died billions of years ago live on in their light, still traveling through space, in the elements they created, in the gravitational waves from their collapse. The first living cells on Earth, long since vanished, persist in their descendants, in the oxygen atmosphere they helped create, in the very fact that life exists at all. This cosmic memory connects you to everything that has ever existed. You're not a separate entity observing the universe from outside, but are woven into its memory, both remembering and being remembered. Every thought you think, every dream you dream, every breath you take adds new information to the cosmic archive. You're both reader and writer of the cosmic memory, accessing ancient information encoded in your atoms, while creating new patterns that will persist in ways you cannot imagine. The question of whether the universe has a delete button thus becomes more complex. It's not just about whether things can be erased, but about what it means to be erased in a universe where everything is connected, where information flows and transforms but might never truly disappear. Perhaps the delete button, if it exists, doesn't destroy information, but transforms it so radically that its original form becomes unrecoverable, like a message encrypted with an unbreakable code, still there but forever hidden. As the night deepens around you, as your breathing continues its slow, peaceful rhythm, let's explore the ways the universe already seems to have mechanisms that work like deletion, natural processes that make things disappear, fade, or transform beyond recognition. These aren't dramatic, frightening events, but gentle, gradual processes that have been happening since the universe began, quiet editors of the cosmic story that shape what remains and what fades away into the darkness between stars. Consider the simple act of starlight fading as it travels through space. A photon of light leaves a star, carrying information about that star's temperature, composition, and state at that exact moment. But as this photon travels through the vast emptiness of space, things happen to it. The expansion of space itself stretches the photon, reducing its energy, shifting its color toward the red end of the spectrum. This cosmological redshift is like a slow forgetting. the universe gradually erasing the original energy of the light, though the information about the star is still there, just encoded in a different form. If that photon travels far enough, billions of light years through expanding space, it can be redshifted so much that it becomes undetectable, its wavelength stretched beyond what any instrument could measure. The information isn't destroyed, but it's been transformed into a whisper so faint that it might as well have been deleted. This is happening to light from the most distant galaxies right now, their stories fading into silence as the universe carries them away from us faster than light itself, not through motion, but through the expansion of space between us and them. But there are more direct forms of cosmic deletion at work. Think about a comet approaching the sun, that ancient ball of ice and dust that has orbited in the cold darkness for billions of years. As it nears our star, the sun's heat begins to sublimate the ice directly into gas, creating the comet's beautiful tail. With each pass near the sun, the comet loses mass, its substance literally boiling away into space. After enough orbits, perhaps a few thousand, perhaps a few hundred depending on the comet's size and orbit, there will be nothing left but a trail of dust, the comet effectively deleted from existence, though its materials persist in a dispersed form. This is deletion as dispersion, not destruction. The comet's atoms still exist, but the pattern that made them a comet has been erased. It's like taking a sandcastle and spreading its sand across the entire beach. The sand remains, but the castle is gone, its information scrambled beyond recovery. The universe is full of such dispersions, patterns dissolving into randomness, structures fading into uniformity, order gently succumbing to entropy's patient persuasion. Stars themselves face this kind of deletion, though on much longer timescales. A star like our Sun will shine steadily for about 10 billion years, fusing hydrogen into helium in its core, maintaining a delicate balance between gravity pulling inward and radiation pressure pushing outward. But eventually the hydrogen in the core runs out, and the star begins to die. For a star like the Sun, this death is relatively gentle. It will expand into a red giant, perhaps swallowing the inner planets, then shed its outer layers into space, creating a planetary nebula, a shell of glowing gas expanding into the darkness. The core will collapse into a white dwarf, a dense remnant about the size of Earth, but with the mass of the Sun. The white dwarf will cool slowly over trillions of years, eventually becoming a black dwarf, a cold, dark object invisible against the background of space. The star that once blazed with the light of billions of hydrogen bombs per second will have been effectively deleted from the visible universe, though its mass, its gravitational influence, its constituent particles will remain. This is deletion through transformation. The star's identity as a star erased, but its substance preserved in a different form. More massive stars face a more dramatic form of deletion through supernova explosion. When a star more than 8 times the mass of our Sun exhausts its nuclear fuel, it can no longer support itself against gravity. The core collapses in less than a second, reaching densities where protons and electrons are crushed together to form neutrons. The outer layers of the star slam into this suddenly solid core and rebound, creating an explosion that can briefly outshine an entire galaxy. The star is torn apart, its material flung into space at speeds of thousands of kilometers per second. In one sense, the star has been deleted, erased from existence in a cosmic instant. But in another sense, it has been transformed into something else, a nebula of hot gas enriched with heavy elements, a neutron star or black hole at the center, gravitational waves rippling outward, neutrinos flying through space, light that will travel for billions of years. The supernova is less a deletion and more a radical transformation, the star's information scattered but not destroyed, like a library whose books have been thrown into the wind but whose words still exist swirling through space. Black holes represent perhaps the most extreme form of apparent deletion in the universe. When matter falls past a black hole's event horizon, it seems to vanish from our universe, deleted from the realm of the observable. The event horizon is not a physical surface, but a boundary in space-time, the point of no return beyond which nothing, not even light, can escape the black hole's gravitational pull. From the outside, it appears that anything falling into a black hole is erased from existence, its information lost forever behind the event horizon's veil. But as we discussed earlier, the situation is more subtle than simple deletion. Stephen Hawking's discovery that black holes emit radiation suggests that they slowly evaporate, returning their mass energy to the universe in the form of particles and radiation. This Hawking radiation appears to be thermal, carrying no information about what fell into the black hole, leading to the information paradox we mentioned. But recent theoretical work suggests that information might be preserved in subtle quantum correlations in the radiation, scrambled beyond easy recognition but not truly deleted. Think of a black hole as the universe's most efficient scrambler rather than its delete button. Information that falls in is processed, mixed, scrambled in ways we don't fully understand, then slowly released back into the universe over vast timescales. A stellar mass black hole would take about 1067 years to evaporate completely through Hawking radiation, a time so long that the current age of the universe is insignificant by comparison. But eventually even black holes face deletion through evaporation, their mass converted back into radiation, their gravitational influence fading until nothing remains but empty space where once there was the universe's most extreme object. The quantum realm offers its own forms of deletion, operating at scales trillions of times smaller than anything we can see. Virtual particles constantly appear and disappear in the quantum vacuum, popping into existence as particle-antiparticle pairs, then annihilating each other typically in about 10^23 seconds. These virtual particles are like thoughts that appear and vanish before they're fully formed, quantum possibilities that are deleted almost as soon as they're created. Yet even these fleeting existences have effects, contributing to the vacuum energy that might be responsible for dark energy and the accelerating expansion of the universe. Quantum decoherence is another form of deletion, where quantum superpositions, states where particles exist in multiple possibilities simultaneously, collapse into single, definite states through interaction with their environment. Before measurement or interaction, an electron might be in a superposition of spinning both up and down simultaneously. But once it interacts with something, this superposition is deleted, replaced by a single, definite spin state. The other possibilities, the other branches of the quantum wave function, seem to vanish, deleted from our reality, though some interpretations of quantum mechanics suggest they might continue to exist in parallel worlds we can no longer access. The quantum eraser experiment demonstrates an even stranger form of deletion. In this experiment, which has been performed many times with consistent results, quantum information about which path a photon took through an apparatus can be erased after the photon has already been detected. When this which path information is erased, an interference pattern appears, as if the photon had taken both paths simultaneously. When the information is preserved, no interference pattern appears, as if the photon took only one path. It's as if the universe can delete not just information, but the consequences of that information having existed, rewriting history at the quantum level. But let's return to larger scales, to processes we can more easily visualize. The universe's expansion itself acts as a kind of cosmic eraser, gradually deleting distant galaxies from our observable universe. Due to dark energy's acceleration of cosmic expansion, galaxies that we can see today are moving away from us faster and faster. Eventually, they will be moving away faster than light, not through space, but with space, carried by the expansion of space-time itself. When this happens, their light will no longer be able to reach us, and they will vanish from our observable universe, deleted from our cosmic horizon. This cosmic event horizon is already deleting information from our view. There are galaxies whose light we can see now, but whose present state we will never observe. If aliens in those galaxies were trying to send us a message today, that message would never arrive. The accelerating expansion of space would carry it away from us, the wavelength stretching to infinity before it could reach Earth. From our perspective, those galaxies' futures are being deleted, erased from the set of things we could ever possibly know. Even within our own galaxy, deletion processes are at work. Stellar winds from massive stars blow away gas and dust, clearing bubbles in the interstellar medium. Supernovae shockwaves compress and heat gas clouds, triggering new star formation while destroying the delicate structures that existed before. Galactic collisions, though happening in slow motion from our perspective, scramble the careful spiral patterns of galaxies, deleting their original structures while creating new ones. Our own Milky Way is on a collision course with the Andromeda Galaxy, and in about 4.5 billion years the two galaxies will merge, their separate identities deleted and replaced by a new, probably elliptical galaxy. The solar wind from our Sun creates another form of deletion, stripping away the atmospheres of planets without strong magnetic fields. Mars, which likely had a thicker atmosphere billions of years ago, has seen most of it deleted by the solar wind, blown away into space molecule by molecule. Venus, despite its thick atmosphere, is also losing gas to space, though at a slower rate. Even Earth loses some atmosphere to the solar wind, though our magnetic field protects us from the worst of it. This atmospheric erosion is a form of slow deletion, gradually erasing the gaseous envelopes that surround planets. Tidal forces provide another deletion mechanism, gradually erasing the separate identities of objects that venture too close to massive bodies. When a comet or asteroid passes too close to a planet or star, tidal forces, the difference in gravitational pull on the near side versus the far side can tear the object apart. We observed this directly in 1994 when comet Shoemaker-Levy 9, torn apart by Jupiter's tidal forces on a previous pass, crashed into the giant planet as a string of fragments. The comet's identity as a single object was deleted, replaced by a series of impacts that left temporary scars in Jupiter's atmosphere. The Roche limit defines the distance within which tidal forces will destroy an orbiting body, deleting its structural integrity. Saturn's rings exist within the planet's Roche limit, which is why they remain as rings rather than coalescing into moons. Any moon that migrates too close to Saturn would be torn apart, its identity as a moon deleted, and its material added to the rings. This is deletion through disintegration, objects pulled apart by the inexorable mathematics of gravity. Radioactive decay represents another form of natural deletion, where unstable atomic nuclei spontaneously transform into different elements. A uranium-238 atom, after existing unchanged for perhaps billions of years, suddenly emits an alpha particle and becomes thorium-234. The original uranium atom has been deleted, replaced by something else. This happens randomly, unpredictably for individual atoms, though statistically predictable for large numbers. Half of any sample of uranium-238 will decay in 4.5 billion years, but we cannot predict which atoms will decay when. This quantum randomness in radioactive decay means that information about when an atom will decay cannot exist until the decay happens. It's not that we don't know when it will decay, it's that this information doesn't exist to be known. The universe itself doesn't know when a particular atom will decay until it happens. This is a form of information that is created and deleted moment by moment, quantum possibilities collapsing into actualities, other possibilities erased from existence. Phase transitions offer another analogy for cosmic deletion. When water freezes into ice, the random motions of liquid molecules are deleted, replaced by the ordered crystal structure of ice. When ice melts back into water, that crystal structure is deleted, replaced by liquid disorder. These transitions preserve the water molecules themselves but delete and create different organizational patterns. The universe might undergo similar phase transitions on cosmic scales, deleting one form of organization and replacing it with another. The early universe went through several such phase transitions. As it cooled from the unimaginable temperatures of the Big Bang, the fundamental forces separated from their original unified state. First gravity separated, then the strong nuclear force, then the weak nuclear force separated from electromagnetism. Each transition deleted the previous unified state, replacing it with something new. The universe we see today, with its four distinct fundamental forces, exists only because previous states were deleted through these phase transitions. Magnetic field reversals on Earth provide another example of natural deletion and recreation. Earth's magnetic field, generated by convection in the liquid iron core, periodically reverses, with north and south poles switching places. During these reversals, which happen on average every few 100,000 years, the magnetic field weakens dramatically, sometimes disappearing almost entirely before rebuilding in the opposite orientation. The old field configuration is deleted and replaced by a new one, though the underlying mechanism that generates the field continues. Even on the largest scales, the universe shows signs of deletion-like processes. The cosmic web, that vast network of galaxy filaments and voids, is constantly evolving. Voids grow larger as galaxies flow toward filaments and nodes. Small structures are deleted through mergers with larger ones. The universe is becoming increasingly clumpy on large scales while becoming increasingly smooth on the very largest scales. The relatively uniform distribution of matter in the early universe has been deleted, replaced by the complex structure we see today. Sound waves in the early universe, called baryon acoustic oscillations, left their imprint on the distribution of galaxies, creating a characteristic scale of about 500 million light-years. But these sound waves themselves were deleted when the universe became transparent to light 380,000 years after the Big Bang. The plasma that carried these sound waves ceased to exist, replaced by neutral gas that couldn't support such oscillations. The waves were deleted, but their fossil imprint remains in the cosmic structure. Let's consider what happens to information in these natural deletion processes. When a star goes supernova, information about its internal structure, the precise arrangement of atoms in its core, the patterns of convection in its envelope, seems to be deleted in the explosion. But this information is transformed rather than destroyed, encoded in the precise details of how the supernova unfolds, the exact distribution of elements in the resulting nebula, the specific frequencies of light emitted, the gravitational waves produced. The information becomes scrambled, spread out, harder to read, but it's still there in principle. This suggests that the universe's natural delete buttons are really transformation mechanisms, ways of scrambling and redistributing information rather than truly destroying it. Even the most violent cosmic events, supernovae, black hole mergers, galactic collisions, preserve information while radically transforming its encoding. The universe might be incapable of true deletion, able only to hide information in increasingly complex ways. But what about the boundaries of our observable universe? As cosmic expansion accelerates, more and more galaxies cross our cosmic event horizon, becoming causally disconnected from us. From our perspective, these galaxies are deleted, erased from the set of things we can ever interact with or observe. But from their perspective, we are the ones being deleted. Each region of space has its own cosmic event horizon, its own observable universe. What appears as deletion from one perspective is just separation from another. This relativity of deletion is important. What seems deleted from one reference frame might be perfectly preserved in another. Information falling into a black hole seems deleted from the outside but might be preserved from the perspective of someone falling in. Galaxies disappearing beyond our cosmic horizon are deleted from our future but continue to exist in their own reference frames. The universe might not have a universal delete button that works the same way for all observers, but rather multiple, perspective-dependent mechanisms that appear to delete information from some viewpoints while preserving it from others. The vacuum of space itself might be subject to deletion and recreation. Quantum field theory suggests that what we call empty space is actually a seething foam of virtual particles and quantum fluctuations. If the vacuum could transition to a lower energy state, a possibility called vacuum decay or false vacuum collapse, our current vacuum would be deleted and replaced by a new one. This would propagate at the speed of light, a bubble of new physics deleting the old, rewriting the laws of nature themselves. This is highly speculative and, if possible at all, extremely unlikely, but it represents the ultimate form of cosmic deletion, erasing not just things within the universe but the very nature of the universe itself. As you continue to rest, your breathing deep and regular, consider how these natural deletion processes connect to your own experience. Your cells are constantly being deleted and replaced, with most of your body's cells turning over every 7 to 10 years. The neurons in your brain are more permanent, but even they change, forming new connections, strengthening some synapses while weakening others. You're not a fixed entity, but a pattern that persists while its substrate constantly changes, like a wave that maintains its form, while the water that comprises it is constantly being replaced. Memory itself involves deletion. To form new memories, old synaptic connections must be weakened or eliminated. Sleep, particularly the deep sleep you're approaching, involves the active deletion of metabolic waste products from the brain, including proteins associated with neurodegenerative diseases. Dreams might be the subjective experience of your brain sorting through the day's experiences, deleting the irrelevant while strengthening the important. Without this nightly deletion, your brain would become cluttered with useless information, unable to function effectively. Cultural evolution also involves deletion. Old ideas are replaced by new ones, outdated technologies are abandoned, languages evolve, and sometimes disappear entirely. The Library of Alexandria, one of the ancient world's greatest repositories of knowledge, was gradually deleted through neglect and destruction. Countless works of literature, science, and philosophy were lost forever, deleted from human knowledge. Yet civilization continued, building new libraries, creating new knowledge, showing that deletion and creation are partners in the dance of cultural evolution. Even in this documentary, as you listen, deletion is happening. The exact words I spoke moments ago are already fading from your immediate memory, replaced by the current words. The specific patterns of neural activity that encoded those earlier words are being overwritten by new patterns. Yet the meaning persists, the overall sense of the ideas remains, even as the specific details are deleted from your conscious awareness. This is how understanding works, not by preserving every detail, but by extracting patterns, keeping what matters while letting the rest fade away. The universe might work the same way, constantly deleting details while preserving patterns, erasing specific configurations while maintaining general principles. The exact positions and velocities of every particle in a gas are constantly changing, being deleted and replaced, but the temperature and pressure of the gas remain stable. The specific atoms in a living organism are constantly being exchanged with the environment, deleted and replaced, but the organism's form and function persist. Perhaps what we call identity, whether of a person, a star, or a galaxy, is not about preserving specific details but about maintaining patterns while allowing the details to be deleted and renewed. This brings us to a profound realization. Deletion might not be the opposite of existence, but an essential part of it. Without deletion, without the ability to erase and start fresh, the universe would become frozen, unable to change or evolve. Every particle would be locked in place by the need to preserve every piece of information forever. Stars couldn't shine because that would delete their hydrogen fuel. Life couldn't evolve because that would delete previous forms. Thought itself would be impossible because it requires the deletion of previous brain states to make room for new ones. The cosmic delete buttons we've explored, these natural processes that erase and transform, are not flaws in the universe but features. They enable change, growth, evolution, and complexity. They create space for new possibilities by clearing away the old. They prevent the universe from becoming cluttered with obsolete information, keeping it dynamic and creative. In this view, the universe's delete buttons are not destructive but generative, not endings but transformations, not losses but opportunities for renewal. As we prepare to transition to examining what it might mean to delete not just things but moments in time itself, let these ideas settle gently in your mind. The universe is engaged in a constant dance of creation and deletion, preservation and transformation, remembering and forgetting. You are part of this dance, your every breath a small act of exchange with the cosmos, taking in new atoms while releasing others, adding your small patterns to the vast cosmic symphony while older patterns fade into silence. Time flows around you now like a gentle river, each moment arriving from the future, pausing briefly in the present, then sliding away into the past. Your heartbeat marks this flow, a steady rhythm that has been with you since before you were born, counting out the seconds of your existence. But what if time isn't really flowing at all? What if every moment, past, present, and future, exists simultaneously in what physicists call the block universe, and what we experience as the flow of time is just our consciousness moving through this fixed structure, like a train passenger watching the landscape pass by the window? And if this is true, what would it mean for the universe to have a delete button that could remove not just objects, but entire moments from this eternal structure? Let's begin with your breath, that gentle rise and fall of your chest that connects you so intimately to the present moment. Each breath takes about 4 seconds, inhale and exhale together. In those 4 seconds, light travels about 1.2 million kilometers, far enough to go to the moon and back with distance to spare. Your heart beats perhaps 4 or 5 times. Billions of neurons in your brain fire in complex patterns, creating your ongoing experience of consciousness. On the quantum level, countless particles interact, wave functions collapse, virtual particles appear and disappear. So much happens in just one breath, and yet it feels like a single, simple moment. But is it really a moment, or is it a collection of even smaller moments, strung together by your consciousness into the illusion of continuity? Scientists and philosophers have long debated whether time is continuous, flowing smoothly like water, or discrete, made up of individual frames like a movie. If time is discrete, there might be a smallest possible unit of time, called Planck time, about 10⁻43 seconds, the time it takes light to travel the smallest meaningful distance in the universe. In 1 second, there would be more Planck times than there have been seconds since the Big Bang. Each of these might be a separate moment that could, in principle, be deleted from the cosmic record. Imagine time as a film strip, each frame a complete three-dimensional snapshot of the entire universe at one instant. In this view, called eternalism or the block universe theory, all moments exist simultaneously. The Big Bang exists, your birth exists, this very moment exists, your future death exists, the heat death of the universe exists, all equally real, all frozen in their respective positions along the timeline. What we experience as the flow of time is just our consciousness accessing these moments sequentially, like reading pages in a book that already exists complete from beginning to end. If the universe had a delete button in this framework, it could potentially remove individual frames from this cosmic film strip. Imagine a moment, perhaps just a single Planck time or perhaps a whole second, simply erased from the sequence. What would happen? Would the frames on either side somehow connect, like splicing a film where a damaged section has been removed? Or would there be a gap, a discontinuity in the flow of time that beings within the universe could somehow detect? The challenge is that we exist within time, embedded in this sequence of moments. If a moment were deleted, we wouldn't experience a gap or a jump because our consciousness, our memories, our very existence would be edited to maintain continuity. It would be like reading a book where a page has been removed so perfectly that the sentences flow seamlessly from the page before to the page after. The story continues to make sense, and unless you had access to another copy of the book, you'd never know anything was missing. Consider your memories of yesterday. You remember certain events, certain moments, but not every second of the day. There are gaps in your memory, hours that passed without leaving any conscious trace. Were those moments deleted from your personal timeline, or do they still exist, just inaccessible to your current consciousness? If someone could delete an hour from yesterday, not just from your memory but from time itself, would you notice? Or would your memories automatically adjust, your life story rewriting itself to maintain consistency? This connects to a deep philosophical question about the nature of time and consciousness. Are you the same person who went to sleep last night? In one sense, obviously yes, you have the same body, the same memories, the same identity, but in another sense, the you of last night no longer exists, except as a memory, a pattern encoded in your current brain state. Every moment you're being deleted and recreated, the previous version of you vanishing into the past as a new version emerges in the present. Sleep makes this particularly apparent, that discontinuity in consciousness where hours pass without subjective experience. Einstein's theory of relativity complicates our picture of time even further. According to relativity, there is no universal now that exists across the entire universe. What counts as the present moment depends on your motion and position in a gravitational field. Two events that appear simultaneous to one observer might happen at different times for another observer moving at a different velocity. This relativity of simultaneity means that if the universe had a delete button for moments, it would face the challenge of determining which moment to delete from whose perspective. Imagine an alien civilization in a galaxy a billion light-years away. From our perspective on Earth, their now is what was happening there a billion years ago, because that's the light we're currently receiving from them. From their perspective, our now is what was happening on Earth a billion years ago. If a cosmic delete button erased a moment from Earth's timeline today, when would that deletion affect them? Would it propagate at the speed of light, taking a billion years to reach them? Or would it happen instantaneously across the universe, violating the cosmic speed limit that nothing can travel faster than light? Quantum mechanics adds another layer of mystery to the nature of time and its potential deletion. In quantum mechanics, particles don't have definite positions and velocities until they're measured. They exist in superpositions of multiple states, all possibilities simultaneously real, until observation collapses them into one outcome. Some physicists interpret this as meaning that time itself branches at every quantum event, creating parallel timelines for every possible outcome. In this many worlds interpretation, deleting a moment wouldn't erase it entirely, but would prune one branch of the ever-dividing tree of timelines. Think of it like this. Every time a quantum event happens, and there are countless such events every instant, the universe splits into multiple versions, one for each possible outcome. You're constantly branching into multiple versions of yourself, each experiencing a slightly different timeline. Most of these differences are too small to notice, a single atom decaying a microsecond earlier or later, but they accumulate over time into dramatically different futures. In this view, the universe's delete button might not erase moments but entire branches of reality, vast trees of possibility pruned from existence. The arrow of time presents another puzzle for our cosmic delete button. Why does time seem to flow in only one direction, from past to future? We can remember the past but not the future. We can affect the future but not the past. Entropy increases over time, never decreases. Eggs can be scrambled but not unscrambled. This directional nature of time is so fundamental to our experience that it's hard to imagine it any other way. But the basic laws of physics are mostly time reversible. If you could reverse the velocity of every particle in the universe, physics suggests that time would run backward, with scrambled eggs reassembling themselves and people growing younger instead of older. If the universe had a delete button for moments, would it respect this arrow of time? Could it only delete moments in the past which have already been fixed, or could it delete moments in the future which haven't happened yet? Or from the block universe perspective where all moments exist simultaneously, would the distinction between past and future be meaningless to such a cosmic mechanism? Perhaps deletion would work the same way regardless of when the deleted moment sits on the timeline. Let's bring this closer to your immediate experience. As you lie there listening, you're creating memories of these words, these ideas. Your brain is encoding this experience in patterns of neural activity that will become long-term memories through a process of consolidation that happens largely during sleep. But what if the moment you're experiencing right now could be deleted? Not just from your memory, but from time itself. The words you're hearing would never have been spoken. The thoughts you're thinking would never have occurred. This gentle journey we're sharing would be erased from the cosmic record. Yet if such deletion were perfect, you wouldn't miss this moment because you would have no awareness it had ever existed. Your timeline would seamlessly skip from the moment before to the moment after, with no sense of discontinuity. You might be listening to a slightly shorter version of this documentary, but it would feel complete to you. The universe would have edited itself, and you, being part of the universe, would be edited too, your memories and experiences adjusted to maintain consistency. This raises the unsettling possibility that such deletions might be happening all the time. Perhaps the universe is constantly editing itself, removing moments that don't fit some cosmic criteria we can't perceive. Maybe there were words in this documentary that were spoken and then deleted, ideas that were expressed and then erased, entire chains of thought that were explored and then removed from the timeline. You would have no way of knowing because your memory of listening would be edited to match the edited reality. Consider déjà vu, that strange feeling that you've experienced a moment before. The conventional explanation is a glitch in memory processing. Your brain accidentally encoding a present experience as a memory, creating the illusion of repetition. But what if déjà vu is actually a glimpse of the universe's editing process? What if it's the feeling of a moment being deleted and then reinserted, or of two similar moments being spliced together, creating a brief echo in consciousness as your brain tries to reconcile slightly different versions of the same experience? Time loops in physics, closed time-like curves where an event can be in its own past, suggest another form of temporal deletion. If such loops exist, and some solutions to Einstein's equations suggest they might be possible near rotating black holes or in universes with certain geometries, then moments within the loop might be simultaneously created and deleted, existing and not existing, happening and unhappening in an eternal cycle. The moment would be preserved but also constantly erased and rewritten, like a cosmic Groundhog Day that nobody within the loop could detect. The grandfather paradox illustrates the complexity of deleting moments from time. If you could travel back in time and prevent your grandfather from meeting your grandmother, you would never be born, which means you couldn't travel back in time to prevent their meeting, which means you would be born, which means you could travel back, and so on. This paradox suggests that either time travel is impossible, or the universe has some mechanism for preventing such paradoxes, perhaps by deleting or editing moments to maintain consistency. One proposed solution is the Novikov self-consistency principle, which suggests that any events that could cause a paradox have zero probability of occurring. The universe essentially deletes paradoxical possibilities before they can happen. Another solution is that attempting to change the past creates a new timeline, deleting your connection to the original timeline while preserving it as a separate branch of reality. In this view, the universe's delete button doesn't erase moments but disconnects them, creating isolated islands of time that can no longer interact. Black holes might already be implementing a form of temporal deletion. At the event horizon of a black hole, time dilation becomes extreme. From the perspective of an outside observer, time slows down more and more as you approach the event horizon, finally stopping entirely at the horizon itself. Objects falling into a black hole appear to freeze at the horizon, their final moments before crossing stretched out to infinity. In a sense, the black hole deletes their future, removing them from the forward flow of time while preserving a frozen image of their last moment. But from the perspective of someone falling into the black hole, time continues normally. They pass through the event horizon without noticing anything special, and continue falling toward the singularity at the center. Their future hasn't been deleted from their perspective, only from the perspective of outside observers. This is another example of how deletion in the universe might be relative, depending on your frame of reference. What's erased from one viewpoint might be preserved from another. The cosmic censorship hypothesis, proposed by Roger Penrose, suggests that the universe might delete certain possibilities to protect the consistency of space-time. According to this hypothesis, singularities, points where the laws of physics break down, are always hidden behind event horizons where they can't affect the outside universe. If a naked singularity, one without an event horizon, tried to form, the universe might delete or edit the conditions that would create it, maintaining the cosmic order by preventing paradoxes and inconsistencies. Quantum mechanics offers its own version of temporal deletion through the quantum Zeno effect. If you observe a quantum system frequently enough, you can prevent it from evolving, essentially deleting its future changes by constantly resetting it to its present state. It's as if the universe has a refresh button that, when pressed repeatedly, prevents time from moving forward for that particular system. This has been demonstrated experimentally with atoms that can be prevented from decaying by frequent observation, their radioactive future deleted by the act of watching. The opposite effect also exists, the quantum anti-Zeno effect, where frequent observations can accelerate a system's evolution, effectively deleting parts of its normal timeline by forcing it to change faster than it naturally would. These quantum effects suggest that observation itself might be a kind of cosmic delete button, able to edit the flow of time for quantum systems by collapsing their wave functions in particular ways. As you continue to rest, your sense of time might be shifting, becoming more fluid, less defined. In the drowsy state between waking and sleeping, minutes can feel like hours, or hours like minutes. Dreams can seem to last for days while only minutes pass in the waking world. This subjective flexibility of time hints at its constructed nature, the way our brains create the experience of temporal flow from the underlying physics of the universe. If our brains can edit our perception of time so dramatically, perhaps the universe itself has similar editorial capabilities on a cosmic scale. Consider the possibility that consciousness itself might be the universe's way of experiencing time, of creating the illusion of flow in a static block universe. Without conscious observers, all moments might exist simultaneously with no distinction between past, present, and future. Consciousness might be what creates the arrow of time, selecting one moment after another to experience, like a cosmic cursor moving through the eternal database of moments. In this view, deleting a moment would mean preventing any consciousness from ever accessing it, removing it from the set of experienceable moments, while it might still exist in some abstract sense. The measurement problem in quantum mechanics might be related to this role of consciousness in creating temporal flow. Before measurement, a quantum system exists in a superposition of states, all possibilities simultaneously real. Measurement collapses this superposition into a single outcome, selecting one possibility and deleting the others. If consciousness is what causes this collapse, as some interpretations suggest, then conscious observation might be constantly editing reality, selecting which possibilities become actual and which are deleted from the timeline. Time crystals, structures that repeat in time rather than space, offer another perspective on temporal deletion. These quantum systems return to their initial state periodically without consuming energy, creating a kind of temporal pattern that persists indefinitely. If a moment within a time crystal's cycle were deleted, would the pattern heal itself like a crystal regrowing a missing section? Or would the deletion destroy the entire pattern, erasing the time crystal from existence? These exotic states of matter, first created in laboratories in 2016, challenge our understanding of time and suggest new ways that temporal information might be preserved or erased. The holographic principle, which we discussed earlier, might apply to time as well as space. If all the information in a volume of space can be encoded on its boundary, perhaps all the information in a period of time can be encoded on its temporal boundaries, the beginning and end of that period. In this view, deleting a moment from the middle of a time period might be impossible without also affecting the boundaries, like trying to remove a page from the middle of a book that's been compressed into its covers. The information would be redistributed rather than destroyed, the timeline adjusting to maintain consistency. As we contemplate these possibilities, your own timeline continues its steady progression. Each heartbeat marks another moment that immediately becomes part of your past, irretrievable except through memory. Each breath adds another layer to your personal history, another frame in the film of your life. You are simultaneously creating and experiencing time, adding new moments while previous ones slip away into the growing archive of your past. The present moment, this very instant as you hear these words, is already becoming a memory, already joining the countless moments that have made up your existence. The question of whether the universe has a delete button for time itself touches on the deepest mysteries of existence. If moments can be erased, then the past is not fixed and the future is not determined. History becomes editable, causality becomes flexible, and the nature of existence itself becomes uncertain. We might be living in a constantly edited reality, where moments are added and removed according to principles we cannot perceive, where our memories and experiences are adjusted to maintain the illusion of continuity. Or perhaps time cannot be deleted, only transformed. Just as energy and information seem to be conserved even through the most dramatic cosmic events, perhaps temporal information is also preserved, encoded in ways we don't yet understand. The moments of your life, every second of your existence, might be permanently etched into the fabric of space-time, impossible to erase even by a cosmic delete button. Your story, once written in time, might be forever part of the universe's eternal narrative. This permanence might be comforting or unsettling, depending on your perspective. Every joy, every sorrow, every ordinary moment of your life preserved forever in the cosmic archive, every mistake permanent, every triumph eternal. Or perhaps the truth is somewhere between these extremes, with some aspects of time editable, while others remain fixed, some moments deletable while others are protected by the fundamental structure of reality. As we prepare to explore what deletion might mean not as erasure but as redirection, consider how your own relationship with time shapes your experience. You cannot change your past, but you can reinterpret it, seeing old events in new lights. You cannot know your future with certainty, but you can influence it through your present choices. You exist at the intersection of the fixed past and the open future, the one point where time is flexible, where new moments are being created and added to the cosmic timeline. Perhaps this is what the universe's delete button really does, not erasing moments but transforming them, not destroying time but editing it into new configurations, like a river that seems to flow steadily forward, but is actually full of eddies and currents, backflows and diversions. Time might be more complex than our linear experience suggests. Moments might be deleted from one timeline only to appear in another, removed from one observer's experience but preserved in another's, erased from local time but maintained in cosmic time. The mystery of time, whether it can be deleted, whether it even exists as we perceive it, remains one of the deepest questions in physics and philosophy. As you drift deeper into relaxation, letting these ideas wash over you like gentle waves, you're participating in this mystery, creating new moments while pondering whether moments can be destroyed. Your consciousness, whatever it ultimately is surfing the wave of time, experiencing the universe's temporal dimension in your own unique way, adding your personal thread to the vast temporal tapestry that connects all things across past, present, and future. Perhaps deletion isn't really deletion at all, but something far more subtle, far more beautiful in its complexity. As you rest there, your breathing steady and calm, imagine reality not as a single thread stretching from past to future, but as a vast river delta, constantly branching and merging, splitting and rejoining, each branch a different possible path through the space of all that could be. What if the universe's delete button doesn't destroy anything but simply redirects the flow, closing off some channels while opening others, guiding reality down different paths without ever truly erasing the possibilities that weren't taken? Think about the choices you've made today, even the small ones. Whether to listen to this documentary, when to start it, how to position yourself comfortably. Each choice created a branch point where reality could have gone different ways. In one version of today, you might not be listening to these words at all. In another, you might have started earlier or later. These alternate versions, these paths not taken, do they simply cease to exist once you've made your choice? Or do they continue somehow, parallel tracks running alongside your experienced reality, close enough to almost touch but forever separated by the thin veil of actuality? The many worlds interpretation of quantum mechanics suggests that every quantum event causes reality to branch, creating parallel universes for every possible outcome. When a radioactive atom might or might not decay in a given moment, both possibilities occur but in different branches of reality. The universe splits, creating two versions, one where the atom decayed, one where it didn't. Both branches are equally real, but they can no longer interact, separated by what we might call quantum deletion, though nothing has actually been destroyed. The other branch hasn't been erased, it's just been redirected down a different path, inaccessible from your branch but continuing its own existence. This branching happens constantly, at every quantum event, and there are countless quantum events happening every instant in every cubic centimetre of space. Right now, in the atoms of your body, electrons are jumping between energy levels, particles are tunneling through barriers, virtual particles are appearing and disappearing. Each of these events creates branches, multiplicities, alternate versions of you experiencing slightly different realities. Most of these differences are too small to notice, but they accumulate over time, like tiny course corrections that eventually lead to completely different destinations. Imagine reality as an enormous tree growing through time, its trunk the Big Bang, its branches all the possible histories that could unfold from that initial moment. Every quantum event creates a new branching point, splitting each branch into multiple smaller branches. By now, after 13.8 billion years of constant branching, the tree has an incomprehensible number of branches, each one a complete universe with its own version of history. Somewhere in this vast tree there are branches where stars formed differently, where Earth never existed, where life never emerged, where you were never born, and there are branches almost identical to yours, differing only in the position of a single atom in a distant galaxy. If the universe has a delete button in this framework, perhaps it doesn't destroy branches but prunes them, like a cosmic gardener shaping the tree of reality. Some branches might be redirected back into others, quantum possibilities that seem to diverge but then reconverge, alternate paths that lead to the same destination. This wouldn't be deletion in the sense of destruction, but a kind of cosmic editing where redundant possibilities are merged, where parallel paths that have become identical are combined back into one. Think about waves on water for a moment. When two waves meet, they interfere with each other, creating patterns of constructive and destructive interference. Where wave peaks meet, they create higher peaks. Where a peak meets a trough, they cancel out, creating calm water. But the waves aren't destroyed by this interference. They pass through each other and continue on their way. The cancellation is temporary, local, a redirection of energy rather than its destruction. Perhaps quantum possibilities work the same way, interfering with each other, sometimes cancelling out, but never truly being deleted. This interference pattern might be what we perceive as reality. All the possible paths interfere with each other, and what we experience is the resulting pattern, the places where possibilities reinforce each other enough to become actual. The paths that destructively interfere, that cancel each other out, might seem deleted from our perspective, but they're still there in the underlying quantum structure, like the waves that continue even after creating a point of calm water. Consider the famous double-slit experiment, where single photons or electrons are fired at a barrier with two slits. When we don't observe which slit the particle goes through, it creates an interference pattern on the detector screen, as if it went through both slits simultaneously and interfered with itself. But when we observe which slit it goes through, the interference pattern disappears, and we see the particle going through just one slit or the other. The act of observation seems to delete one possibility, forcing reality to choose a single path. But what if observation doesn't delete the other possibility, but simply redirects our consciousness down one branch while the other continues unobserved? In this view, every observation, every measurement, every interaction that collapses a quantum superposition is actually a branching point where consciousness follows one path while the other paths continue without us. The universe's delete button might not be a button at all but a switch, redirecting conscious experience down different tracks of an eternally branching railway system. Your own consciousness might be constantly switching tracks without you realizing it. Every time you make a decision, every time a quantum event in your brain resolves one way rather than another, you might be switching to a slightly different branch of reality. The continuity you experience, the sense of a single, coherent timeline, might be an illusion created by consciousness, always following the path of its own observations, unable to perceive the branches it's not taking. This could explain some puzzling aspects of consciousness and free will. When you decide to move your hand, neural activity preparing for the movement can be detected before you're consciously aware of deciding. It's as if the decision has already been made by the time you experience making it. Perhaps what you experience as deciding is actually your consciousness, switching to the branch where that decision was made, redirecting itself to the timeline where your hand moves. The other branch, where you decided not to move your hand, continues without your consciousness, experienced by another version of you who made a different choice. Dreams might offer a glimpse into this branching nature of reality. In dreams, the normal rules don't apply, causality is fluid, and impossible things happen routinely. Perhaps during dreams, consciousness loosens its grip on a single branch and experiences multiple possibilities simultaneously or rapidly switches between nearby branches. The bizarre, shifting nature of dreams might be what reality looks like when you're not firmly locked onto a single timeline, when the universe's redirect function is operating more freely. Let's think about probability for a moment. When we say there's a 50% chance of a coin landing heads, what do we mean? In the many worlds view, the coin lands heads in 50% of the branches and tails in the other 50%. The probability isn't about uncertainty, but about the proportion of branches where each outcome occurs. When you flip the coin and see heads, you've been redirected to one of the heads branches, but the tails branches still exist, experienced by other versions of you who saw the coin land differently. This raises a profound question about identity. Are all these versions in different branches equally you? Or is there something special about the branch you're experiencing that makes it the real one? Perhaps identity itself is more fluid than we imagine, constantly splitting and merging like the branches of reality. You might not be a single continuous entity, but a constantly branching tree of experiences, each branch equally valid, equally real, equally you. The universe's delete button, in this context, might work by pruning some branches of your identity tree while allowing others to flourish. Branches that lead to contradictions, to impossible situations, to violations of physical laws might be automatically redirected back into viable branches. This would be a kind of cosmic error correction, reality editing itself to maintain consistency, deleting impossible futures by preventing them from branching off in the first place. Consider the anthropic principle, the observation that the universe seems fine-tuned for the existence of observers like us. If the fundamental constants were even slightly different, stars wouldn't form, chemistry wouldn't work, life would be impossible. In a single universe, this fine-tuning seems impossibly unlikely. But if reality is constantly branching, and consciousness can only follow branches where observers exist, then we necessarily find ourselves in a branch compatible with our existence. All the branches where observers can't exist are effectively deleted from our experience, redirected away from consciousness. This selective branching might happen at every scale. At the quantum level, particles follow paths that minimize action, as if they're selecting the most efficient route through space-time. At the biological level, evolution selects for survival and reproduction, redirecting life down paths of increasing complexity and adaptation. At the conscious level, attention selects which perceptions to process, redirecting awareness toward what seems important. Each level might have its own version of the universe's delete button, pruning possibilities to shape the flow of reality. Memory itself might work through selective branching. When you try to remember something, multiple possible memories might be activated, different versions of past events. Your brain selects one, redirects consciousness down that memory path, while the others fade back into the unconscious. False memories might occur when consciousness is redirected down the wrong branch, accessing a memory from a slightly different timeline. The Mandela effect, where large groups of people remember events differently from recorded history, might be glimpses of alternate branches bleeding through. The future might work similarly. When you imagine possible futures, you're exploring different branches, different ways reality might unfold. Planning is the process of selecting which branches to try to follow, which paths to make more probable through your actions. Worry is getting stuck contemplating branches you don't want to experience. Hope is focusing on branches you do want. The universe's redirect function might be influenced by consciousness in ways we don't yet understand, our expectations and intentions subtly affecting which branches become actual. But let's return to the cosmic scale. If reality is constantly branching, the universe is becoming increasingly complex over time, an ever-growing tree of possibilities. Yet we observe a universe that seems to have consistent laws, predictable behaviors, stable structures. How can both be true? Perhaps the vast majority of branches are so similar that they're effectively identical, like the many individual water molecules that together create a smooth-flowing river. The universe might be deleting redundancy, merging branches that have become indistinguishable, keeping the tree of reality from growing beyond all bounds. Black holes might be massive redirect engines, taking in matter and information from many branches and mixing them together before releasing them through Hawking radiation. The information isn't destroyed but is scrambled across branches, redistributed through the multiverse. What falls into a black hole in one branch might emerge from a white hole in another, or be spread across many branches in tiny increments. The event horizon might not be a point of deletion, but a point of maximum redirection, where paths diverge so dramatically that they can never reconverge. The expansion of the universe might also be a form of redirection. As space expands, different regions become causally disconnected, unable to interact. Each region might branch independently, creating separate trees of reality that can no longer interfere with each other. What looks like deletion from one region's perspective, galaxies disappearing beyond the cosmic horizon, might be redirection into independent branches of the multiverse. The universe might not be getting emptier, but might be branching into multiple universes that can no longer see each other. Dark energy, that mysterious force accelerating cosmic expansion, might be the universe's redirect mechanism operating on the larger scales. It might be spreading branches apart, preventing them from interfering with each other, creating space for new possibilities, or it might be the pressure of all those accumulating branches, the multiverse growing so rapidly that each branch experiences it as accelerating expansion. What we perceive as empty space might be full of other branches, separated from us by the thinnest of veils, but contributing to the overall structure of reality. Quantum tunneling offers another window into reality's redirect function. Particles can tunnel through barriers that classical physics says they shouldn't be able to cross, appearing on the other side without having enough energy to go over the top. Perhaps they're not actually tunneling but switching branches, redirecting to a timeline where they were always on the other side. The barrier hasn't been penetrated, reality has been edited to create a path around it. This might be how the universe solves problems that seem impossible from a single timeline perspective. When faced with a paradox or contradiction, reality might redirect around it, finding branches where the paradox doesn't occur. The universe's delete button might be less about removing problems and more about navigating around them, like water finding its way around obstacles, always flowing toward possible futures while avoiding impossible ones. As you lie there, perhaps feeling yourself beginning to drift, your consciousness might be gently switching between nearby branches, micro adjustments to keep you on a stable path through reality. Each breath might be selecting from countless possible breaths, each heartbeat choosing from quantum variations, your body and mind constantly redirecting through the space of possibilities to maintain the coherent experience you call being yourself. Sleep itself might be a major redirect event. As consciousness withdraws from external perception, it might loosen its lock on a single branch, allowing more fluid movement through nearby possibilities. This could be why sleep is so essential for creativity and problem-solving. During sleep, consciousness can explore alternate branches, finding solutions that aren't accessible from your waking branch. When you wake with a sudden insight, you might have been redirected to a branch where that insight was always available. The placebo effect might be another example of consciousness-driven redirection. When you believe a treatment will work, you might redirect yourself to branches where it does work, where your body's healing mechanisms are more active, where recovery is more likely. The treatment itself might be irrelevant. What matters is the redirection of consciousness toward healing branches. This isn't just positive thinking, but might be an actual navigation through the multiverse, selecting paths that lead to better outcomes. Consider how this redirect model changes the meaning of death. In a single timeline, death is the ultimate. Deletion, the end of consciousness, the termination of experience. But if reality is constantly branching, death might be just another redirect. In some branches you die, in others you survive. Consciousness, unable to experience its own non-existence, might always find itself in branches where it continues. This is the quantum immortality hypothesis, the idea that consciousness always follows branches where it survives, no matter how improbable. This doesn't mean you're immortal in any conventional sense. The branches where you survive might become increasingly rare, increasingly improbable, requiring ever more unlikely coincidences to maintain consciousness. But from your subjective perspective, you would always find yourself in one of these surviving branches, experiencing an increasingly strange and improbable world as the reasonable branches where you died are redirected away from your experience. The universe's delete button, in this view, doesn't delete you but redirect you, constantly adjusting your path through the multiverse to maintain the continuity of experience. What feels like a single life might be a complex path through countless branches, consciousness following the only route it can, the one where it continues to exist. Every close call, every near miss, every moment where things could have gone wrong but didn't, might be points where consciousness was redirected away from branches where it would have ended. But this raises troubling questions. If consciousness always redirects to branches where it continues, why do we observe death at all? Why do other people die from our perspective? Perhaps consciousness is more complex than simple existence or non-existence. Perhaps it can split, with parts following different branches, or merge, with multiple branches combining into one experience. Death might be a redirect that we can observe in others but never experience ourselves, always finding ourselves in the branches where we're the observers rather than the observed. As we contemplate these possibilities, reality continues its constant branching around us. Every photon that hits your retina creates branches. Every sound wave that reaches your ear splits reality into possibilities. Every thought that forms in your mind selects from infinite variations. You're not just moving through a fixed reality, but actively participating in its creation, your observations and choices helping to determine which branches become actual, which possibilities are redirected into your experience. The universe might not need a delete button because nothing ever needs to be deleted. Every possibility, every branch, every alternate path might continue to exist in the vast multiverse, even if consciousness can only experience one path at a time. Deletion might be an illusion created by our limited perspective, unable to see the branches we're not taking, the possibilities we're not experiencing. From a God's eye view of the entire multiverse, nothing is ever deleted, only redirected, reality constantly flowing through the space of all possibilities like an infinite river finding infinite paths to the sea. This redirect model suggests a universe far stranger and more wonderful than we usually imagine. Not a single story, but an infinite library of stories all being written simultaneously. Not a single path, but an endless labyrinth of paths, all being walked at once. Not a single reality, but a multiverse of realities, interfering and branching and merging in patterns too complex for our single-threaded consciousness to fully grasp. The delete button might be just our limited way of understanding a redirect function that operates on scales and in dimensions we can barely conceive. As you rest there, perhaps beginning to feel the gentle pull of sleep, you might be approaching one of those major redirect points, where consciousness loosens its grip on a single branch and begins to explore the wider possibilities. Dreams await, those strange journeys through alternate branches where the usual rules don't apply, where deleted possibilities might be recovered, where redirect paths might be explored. In sleep, you might experience what the universe is like when the delete button is revealed to be something else entirely, not an eraser but a guide, not an ending but a transformation, not a loss but a journey into possibilities you haven't yet imagined. Within you, right now, a gentle deletion is taking place. As you rest there, listening to these words, your brain is quietly deciding what to keep and what to let go, which of today's experiences will become lasting memories and which will fade into the background hum of forgotten moments. This isn't a failure of your memory, but its essential function, a biological delete button that keeps your mind from becoming overwhelmed with irrelevant details, creating space for what truly matters. You are, in this very moment, both remembering and forgetting, holding on and letting go, pressing your own small delete buttons in rhythm with your breath. Think about this morning, those first moments of waking. Can you remember the exact first thought that crossed your mind? The precise sensation of consciousness returning from sleep? Most likely these details have already been deleted, deemed unimportant by the ancient algorithms of your brain, discarded to make room for more significant information. This forgetting isn't a flaw, but a feature, evolved over millions of years to help our ancestors survive by focusing on what mattered. Threats, opportunities, social bonds, patterns that predicted future events. The ability to forget, to delete the irrelevant, might be just as important as the ability to remember. Your brain contains roughly 86 billion neurons, each connected to thousands of others through synapses, creating a network of such complexity that we're only beginning to understand how it works. Each synapse can be strengthened or weakened, connections can be formed or broken, entire networks can be reorganized. This constant restructuring is how you learn, how you adapt, how you become who you are. But it's also how you forget, how you let go, how you delete old patterns to make room for new ones. Every moment of learning involves some amount of forgetting. Every new memory potentially overwrites or modifies existing ones. Sleep, which you're gradually approaching, is when much of this deletion happens. During the day, your brain accumulates not just memories but also metabolic waste products, cellular debris, the physical residue of thinking and experiencing. During sleep, especially during deep slow-wave sleep, your brain's glymphatic system activates, flushing out these waste products, literally cleaning your brain. Beta amyloid, the protein associated with Alzheimer's disease, is one of the substances cleared during sleep. Without this nightly deletion, this cellular house cleaning, your brain would become cluttered with debris, unable to function properly. But sleep does more than just physical cleaning. It's also when your brain sorts through the day's experiences, deciding what to consolidate into long-term memory and what to discard. During REM sleep, when most dreams occur, your brain seems to be processing emotional memories, integrating them into your existing understanding of the world. The bizarre nature of dreams might be your brain's way of testing different combinations of memories, different associations, keeping what's useful and deleting what's not. Those strange dream scenarios where people from different parts of your life appear together, where locations blend and shift, might be your brain experimenting with different ways of organizing information, trial deletions and reconstructions that help optimize your memory. Consider the last time you learned something new, perhaps a skill or a piece of information that initially seemed difficult, but gradually became second nature. That learning process involved not just adding new neural connections, but also removing old ones, deleting inefficient pathways, and replacing them with more streamlined routes. When a child learns to walk, they don't just develop the neural circuits for walking, they also prune away the excessive connections that produce unnecessary movements, the random flailing that characterizes infant motion. Expertise in any domain involves as much deletion as addition, removing the irrelevant to reveal the essential. This principle extends beyond individual learning to the development of the brain itself. During childhood and adolescence, the brain undergoes massive synaptic pruning, deleting up to half of the synaptic connections formed in early childhood. This might seem like a loss, but it's actually a refinement, like a sculptor removing excess marble to reveal the statue within. The connections that remain are the ones that have proven useful, that have been reinforced by experience. This deletion of excess connections is what allows the adult brain to function efficiently, to process information quickly without getting lost in a maze of possibilities. Mental health often involves problems with these deletion mechanisms. Depression can involve an inability to let go of negative thoughts and memories, recycling them endlessly instead of deleting them and moving on. Anxiety might be partly a failure to delete unlikely threats, keeping them active in consciousness when they should be dismissed. PTSD involves memories that refuse to be properly processed and filed away, remaining vivid and intrusive when they should fade into the past. These conditions show us what happens when our personal delete buttons malfunction, when we can't let go of what needs to be released. But forgetting isn't just about mental health, it's essential for creativity and problem solving. When you're stuck on a problem and then take a break, returning later with fresh insight, what's happened is that your brain has deleted its fixation on unsuccessful approaches, allowing new perspectives to emerge. The aha moment often comes after a period of not thinking about the problem, when conscious attention has been deleted and unconscious processing has been allowed to explore different paths. This is why sleep, walks, showers, and other activities that allow the mind to wander are so often associated with creative breakthroughs. Your immune system has its own delete buttons. T cells that would attack your own body are deleted during development in a process called negative selection. Cells that become damaged or infected can trigger their own deletion through apoptosis, programmed cell death that removes them before they can cause harm. Cancer often involves a failure of these deletion mechanisms, cells that should die instead continuing to divide, accumulating mutations that should trigger their removal. Your body is constantly deciding which cells to keep and which to delete, maintaining the delicate balance that is health. Even your DNA involves deletion. As cells divide, the telomeres at the ends of chromosomes get shorter, eventually triggering cell death when they become too short. This is a kind of genetic delete button, limiting how many times most cells can divide, preventing the accumulation of errors that comes with repeated copying. Some scientists think aging itself is partly about the accumulation of cellular damage that should be deleted but isn't, the gradual failure of our biological deletion mechanisms. But let's return to the kind of deletion you have more conscious control over, the letting go of experiences, relationships, and attachments that no longer serve you. Every ending is a kind of deletion, removing something from your active life to make room for something new. When a relationship ends, when you leave a job, when you move from a familiar place, you're pressing a delete button on one chapter of your life. This can be painful, like deleting a file you've worked on for years, but it's also necessary for growth and change. Consider how you've changed over the years. The person you were a decade ago had different beliefs, different priorities, different dreams. Some of those have been deleted, replaced by new understandings, new values, new aspirations. This isn't betrayal of your past self, but evolution, the natural process of updating and refining who you are. If you couldn't delete outdated versions of yourself, you'd be stuck, unable to grow, trapped in patterns that no longer fit your life. Forgiveness is perhaps the most powerful delete button we have. When you truly forgive someone, including yourself, you're deleting the hold that past hurt has on your present experience. You're not erasing the memory of what happened, but you're removing its emotional charge, its ability to cause ongoing pain. Forgiveness doesn't mean forgetting in the sense of amnesia, but forgetting in the sense of releasing, letting go of the anger or hurt that keeps you connected to painful past events. Meditation and mindfulness practices are, in many ways, exercises in conscious deletion. When you meditate, you practice letting thoughts arise and then letting them go, deleting your attachment to them. You observe the constant stream of mental activity without getting caught up in it, allowing thoughts and sensations to delete themselves naturally as your attention returns to the breath or another focus point. This practice of non-attachment, of allowing experiences to arise and pass without clinging to them, is a form of psychological hygiene, clearing out mental clutter as it accumulates. The digital age has given us new forms of deletion to navigate. We can delete emails, messages, photos, posts, even entire online personas. But as we discussed earlier, digital deletion is rarely complete. Screenshots persist, caches remember, servers retain backups. Our digital lives have made deletion both easier and harder, giving us delete buttons everywhere while making true erasure almost impossible. The right to be forgotten, enshrined in some privacy laws, acknowledges our need for deletion in the digital realm, the importance of being able to move on from past digital selves. Social media has complicated our relationship with deletion. The permanent record of our posts and photos can make it hard to let go of past versions of ourselves. Old embarrassments remain visible, past relationships haunt our timelines, former opinions we've since deleted from our minds remain written in digital stone. Yet we also carefully curate these online selves, deleting posts that no longer represent us, untagging photos we don't like, unfriending or blocking people we need to move on from. These digital delete buttons have become part of how we manage our identities and relationships. But there's something important to remember about human deletion. It's rarely absolute. When you forget something, the memory isn't usually completely erased but becomes inaccessible, potentially recoverable given the right cues. When you let go of an attachment, traces often remain, ready to be reactivated by a familiar smell, a piece of music, a random association. When you forgive, the hurt might be deleted from your active experience, but the wisdom gained from the experience remains. Human deletion is more like archiving than destroying, moving things from active memory to deep storage, where they can still influence us in subtle ways. This is reflected in how therapy often works. Rather than trying to delete traumatic memories or painful experiences, therapy helps reprocess them, changing their meaning and impact. The memory remains, but its power to cause suffering is deleted. The event is recontextualized, integrated into a broader understanding of your life story. This isn't erasure, but transformation. Not forgetting, but remembering differently. Deleting not the experience, but its ability to define you. Your body holds memories that your conscious mind has deleted. Muscle memory allows you to perform complex actions without conscious thought, riding a bike or typing on a keyboard even if you can't consciously remember learning these skills. Emotional memories can be triggered by physical sensations, a tightness in the chest bringing back anxiety, a warmth in the belly recalling comfort. These body memories show that deletion in one system doesn't mean deletion in all systems. You are a collection of interconnected memory systems, each with its own patterns of retention and deletion. Language itself involves constant deletion. As you listen to these words, you're deleting most of the acoustic detail, keeping only what's necessary to extract meaning. You don't remember the exact pitch of each syllable, the precise timing of each pause, the subtle variations in pronunciation. Your brain deletes these details almost immediately, converting sound waves into meaning and discarding the raw data. This deletion is so automatic that you're usually not even aware it's happening, experiencing meaning directly without noticing the complex process of deletion and extraction that creates it. Reading involves similar deletion. Your eyes don't move smoothly across text, but jump from point to point in movements called saccades. During these jumps, vision is suppressed, effectively deleted to prevent motion blur. You're blind for a significant portion of the time you're reading, but your brain deletes these gaps from your experience, creating the illusion of continuous vision. The words you're not currently looking at directly are also partially deleted from conscious processing, held in peripheral awareness, but not fully attended to until your eyes land on them. Even consciousness itself might be a process of deletion. Of all the information your senses gather, only a tiny fraction makes it to conscious awareness. Your brain is constantly deciding what to delete from consciousness, what to filter out as irrelevant background. This selective attention is what allows you to focus on these words despite whatever other sounds, sensations, and thoughts might be present. Consciousness might not be about what we're aware of, but about what we've successfully deleted from awareness. The vast amount of information we're not conscious of that allows the small amount we are conscious of to stand out. As you move through life, you're constantly pressing small delete buttons, most of them unconsciously. You delete old cells and grow new ones. You delete outdated beliefs and form new understandings. You delete expired relationships and form new connections. You delete yesterday's worries and face today's challenges. This constant deletion is not loss but renewal, not emptying but making space, not ending but transforming. The fear of deletion, of forgetting, of being forgotten is deeply human. We create monuments, write books, take photographs, all in an attempt to resist deletion, to preserve something of ourselves beyond our biological expiration date. Yet perhaps there's wisdom in accepting deletion as a natural and necessary part of existence. Just as the universe might need its cosmic delete button to continue functioning, We need our personal delete buttons to continue growing. Consider the liberation that comes from letting go, from pressing that delete button on something you've been holding onto for too long. The relief of finally discarding old belongings that no longer serve you, the freedom of releasing a grudge you've been nurturing, the space that opens up when you delete an obligation that was draining your energy. These deletions aren't losses but gains, creating room for new experiences, new relationships, new aspects of yourself to emerge. As sleep approaches, as your conscious mind prepares for its nightly deletion and consolidation process, you might reflect on what you're ready to let go of. What memories are you holding that could be released? What attachments are you maintaining that could be deleted? What versions of yourself are you preserving that could be updated? Sleep offers a natural opportunity for these deletions, a time when your brain can sort through the accumulated experiences and decide what to keep and what to release. The delete button in your life isn't something to fear but something to embrace. It's the mechanism that allows change, growth, healing, and renewal. Without the ability to forget, to let go, to move on, you would be frozen, trapped in every moment that ever was, unable to experience the freshness of now. Your capacity for deletion is what makes you dynamic, adaptive, capable of learning and changing throughout your life. Tomorrow, when you wake, you'll be slightly different from who you are right now. Some of today will have been deleted, deemed unimportant by your sleeping brain. Some will have been consolidated, woven into the fabric of who you are. New, neural pathways will have formed while others weakened. You'll have pressed countless biological delete buttons, clearing out cellular waste, resetting neurotransmitter levels, pruning synaptic connections. You'll wake refreshed precisely because of these deletions, ready to face a new day with a cleaned and optimized brain. This is the gift of our personal delete buttons. They allow us to be constantly reborn, continuously updated versions of ourselves. We're not fixed entities but flowing processes, rivers of experience that maintain their identity while constantly changing their substance. Every deletion is a small death that enables continued life, every forgetting a space for new remembering, every letting go a preparation for new holding. As we prepare to explore how science observes these processes of cosmic and personal deletion, let the idea of beneficial deletion settle into your relaxing mind. You don't need to hold on to everything. You don't need to remember everything. You don't need to be everything you've ever been. You can let go, you can forget, you can delete, and in doing so, you can continue becoming. The delete button isn't an ending, but a beginning. Not a loss, but a transformation. Not something to resist, but something to embrace as an essential part of the beautiful, complex, ever-changing process of being human. In the gentle darkness behind your closed eyelids, deletion is already beginning. The day's unnecessary details are being cleared away. The tension in your muscles is being released. The worried thoughts are being allowed to dissolve. This is your nightly practice of letting go, your biological and psychological delete buttons working in harmony to prepare you for restoration and renewal. And in this deletion, in this letting go, you're participating in the same cosmic process we've been exploring, the universal dance of holding and releasing, remembering and forgetting, being and becoming. Far above the Earth's atmosphere, beyond the distorting effects of air and weather, a metal eye the size of a school bus drifts through the vacuum, its mirror constantly gathering ancient light. This is the Hubble Space Telescope, one of humanity's windows into the cosmic deep, and for over 3 decades it has been watching, recording, searching for any signs that reality might not be as continuous and unbroken as it appears. As you rest there, breathing slowly and steadily, Hubble and its companions are engaged in their patient vigil, collecting photons that have travelled for billions of years, reading the universe's autobiography written in light, looking for gaps, inconsistencies, or evidence that something, somewhere, might have been deleted from the cosmic story. The data streams down from these orbital observatories in an endless river of numbers, measurements of brightness and colour, position and motion, composition and temperature. Scientists on Earth decode these numbers like archaeologists deciphering ancient texts, looking for patterns, anomalies, anything that might hint at cosmic editing. So far, the story the data tells is remarkably consistent. The laws of physics appear to be the same in distant galaxies as they are in our laboratories. The speed of light measured from ancient supernovae matches what we measure today. The cosmic microwave background radiation shows the same patterns in every direction, with tiny variations that match our theoretical predictions almost perfectly. If the universe has a delete button, it seems to operate so smoothly that it leaves no obvious traces, no glitches in the matrix that our instruments can detect. But absence of evidence isn't evidence of absence, as scientists like to say. Our instruments, magnificent as they are, can only detect certain kinds of signals, only measure certain properties of the universe. The James Webb Space Telescope, Hubble's younger and more powerful sibling, can see infrared light from the universe's earliest galaxies, but it cannot see dark matter directly. The LIGO and Virgo gravitational wave detectors can sense the ripples in space-time from colliding black holes billions of light years away, but they cannot tell us what happens to information that falls into those black holes. We're like people trying to understand an ocean by studying the waves on its surface, able to see patterns and movements but unable to perceive the full depth of what lies beneath. Consider what our telescopes actually see when they look at distant galaxies. The light from a galaxy 10 billion light-years away, left when the universe was less than 4 billion years old. During its journey to us, that light has been stretched by the expansion of space, shifted toward the red end of the spectrum. It has been bent by the gravity of intervening galaxies and dark matter, a phenomenon called gravitational lensing that can create multiple images of the same galaxy or distort its appearance into arcs and rings. By the time this ancient light reaches our detectors, it has been processed by the universe itself, edited by its passage through space and time. The Gaia spacecraft, orbiting the Sun alongside Earth, is creating the most detailed three-dimensional map of our galaxy ever made, measuring the positions and motions of over 1 billion stars. Each star's position is measured multiple times over years, allowing Gaia to detect their tiny movements across the sky. This data reveals the galaxy's history, showing streams of stars from smaller galaxies that the Milky Way has consumed. Like looking at tree rings to read the story of past seasons, if stars were being deleted from our galaxy, if portions of its history were being erased, Gaia would see discontinuities, gaps in the stellar streams, stars whose motions don't match their neighbours. So far, everything follows the expected patterns, the galaxy's history appearing unedited and complete. The Sloan Digital Sky Survey has mapped millions of galaxies, creating a three-dimensional map of the large-scale structure of the universe. This cosmic web, as we've discussed, shows galaxies arranged in filaments and walls separated by vast voids. The pattern matches what computer simulations predict, starting from the tiny fluctuations in the cosmic microwave background and letting gravity shape matter over billions of years. If large portions of the universe were being deleted, we would expect to see irregularities in this structure, places where the pattern breaks down, where galaxies are missing or arranged in ways that gravity alone cannot explain. Instead, we see a universe that appears to have evolved smoothly from its initial conditions, each piece connected to its neighbours in an unbroken web of cause and effect. But there are mysteries in the data, puzzles that might hint at something deeper. Dark matter, which we can only detect through its gravitational effects, makes up about 27% of the universe's mass-energy content. We see its influence in the rotation of galaxies, which spin too fast to be held together by the gravity of visible matter alone. We see it in gravitational lensing, where the bending of light is stronger than the visible matter can account for. We see it in the cosmic microwave background, where its gravitational effects left subtle imprints on the early universe. Yet we cannot see dark matter directly, cannot detect the particles it's made of despite decades of searching. Is dark matter a form of cosmic information that has been partially deleted, present in its effects but erased from direct observation? Dark energy presents an even deeper mystery. Making up about 68% of the universe's mass-energy content, dark energy is causing the expansion of the universe to accelerate, pushing galaxies apart at an ever-increasing rate. We can measure this acceleration by observing distant supernovae, stellar explosions that serve as standard candles, their intrinsic brightness known so we can calculate their distance from how dim they appear. These observations, first made in 1998 and confirmed many times since, show that the universe's expansion has been accelerating for the past 5 billion years. But we don't know what dark energy is, whether it's a property of space itself, a new kind of field, or something even stranger. Could dark energy be the universe's delete mechanism in action, gradually erasing the connections between different regions of space. The Planck satellite mapped the cosmic microwave background with unprecedented precision, measuring temperature variations of just a few parts per million across the entire sky. This ancient light shows us the universe as it was 380,000 years after the Big Bang, when it first became transparent to light. The patterns in this radiation match our theoretical predictions remarkably well, but there are some anomalies. The cold spot, a region about 1 billion light-years across that's slightly cooler than expected. The axis of evil and unexpected, alignment of certain patterns that seems to define a special direction in space. These could be statistical flukes, or they could be hints that something has been edited out of the cosmic story, deleted regions whose absence creates these subtle anomalies. When we look at the distribution of matter in the universe, we find that it's not quite as clumpy as our models predict. This is called the S8 tension, a discrepancy between measurements of matter clustering in the early universe versus today. It's as if some of the clumpiness has been smoothed out, deleted or redistributed in ways we don't understand. Different methods of measuring this clustering give slightly different results, a puzzle that has persisted despite increasingly precise observations. Is this evidence of cosmic deletion, some process that erases structure on certain scales while preserving it on others? The Hubble tension is another persistent puzzle. Different methods of measuring the universe's expansion rate give different values. Measurements based on the cosmic microwave background suggest one rate, while measurements based on nearby supernova and variable stars suggest a faster rate. It's as if the universe is expanding at different rates depending on how you measure it, or as if something about cosmic history has been edited between the early universe and today. Scientists have proposed various solutions, from new physics to measurement errors, but the tension persists, a crack in our cosmic understanding that might hint at deletion or editing on cosmic scales. Neutrinos, those ghostly particles that barely interact with matter, carry information about the most extreme events in the universe. The IceCube Neutrino Observatory, buried deep in Antarctic ice, detects the rare occasions when high-energy neutrinos interact with atoms in the ice. These neutrinos come from distant cosmic accelerators, places where particles are accelerated to energies far beyond what we can achieve on Earth. But many of the neutrinos IceCube detects have no obvious source, no visible cosmic event that could have produced them. Are these orphan neutrinos evidence of deleted events, cosmic catastrophes that have been erased from the electromagnetic spectrum, but whose neutrinos still carry the memory? The ALMA telescope array in Chile's Atacama Desert observes the universe in millimeter and submillimeter wavelengths, seeing through dust clouds that block visible light. ALMA has revealed stellar nurseries where new stars are being born, protoplanetary disks where planets are forming, and the cold gas in distant galaxies that will fuel future star formation. This cold universe, invisible to optical telescopes, contains much of the raw material for cosmic construction. If the universe were deleting matter on large scales, ALMA would see the evidence in disrupted gas flows, in star formation rates that don't match the available material, in chemical abundances that don't follow the expected, patterns of stellar nucleosynthesis. The Chandra X-ray Observatory and XMM Newton see the universe's violent side, detecting X-rays from gas heated to millions of degrees. They observe the hot gas in galaxy clusters, the accretion disks around black holes, the shock waves from supernova explosions. This high-energy universe reveals processes that could potentially delete information. Matter falling into black holes, particles accelerated to near-light speed, magnetic fields powerful enough to tear atoms apart. Yet even in these extreme environments, the laws of physics appear to hold, information seems to be conserved even if scrambled, and the cosmic story continues without obvious breaks or discontinuities. Radio telescopes like the Very Large Array and the upcoming Square Kilometre Array detect radio waves from cosmic sources, from the hydrogen gas that fills space, to the jets from active galactic nuclei, to the pulsing signals from neutron stars. Pulsars, rapidly rotating neutron stars that emit regular radio pulses, are some of the most precise clocks in the universe. Their pulses are so regular that we can detect gravitational waves passing by Earth from the tiny changes they cause in pulse arrival times. If time itself were being deleted, if moments were being erased from the cosmic timeline, pulsars would show irregularities, glitches beyond the occasional starquakes they experience. Instead, they keep remarkably steady time, their pulses arriving with predictable precision that suggests an unedited flow of time. Fast radio bursts, brief but intense pulses of radio waves from distant galaxies, were once thought to be equipment malfunctions or terrestrial interference. Now we know they're real cosmic phenomena, though we're still not sure what causes most of them. Some repeat, some don't. Some come from magnetars, highly magnetized neutron stars, while others have no obvious source. Could these bursts be echoes of cosmic deletion events, the radio screams of matter or information being erased? Or are they natural processes we simply don't understand yet, new physics rather than evidence of a cosmic delete button? The search for extraterrestrial intelligence, CT, represents another way of looking for cosmic anomalies. If intelligent civilizations exist elsewhere in the universe, they might have discovered things about reality that we haven't, including potential deletion mechanisms. The Breakthrough Listen project uses some of the world's largest radio telescopes to search for artificial signals from other civilizations. So far, despite decades of searching and examining millions of stars, we've found no confirmed signals from alien technology. This great silence, as it's called, might itself be evidence of cosmic deletion. Perhaps civilizations that advance far enough discover something that causes them to be deleted, or to delete themselves, or to transcend our observable universe entirely. Cosmic rays, high-energy particles that constantly bombard Earth from space, carry information about the most energetic processes in the universe. The Piero J Observatory in Argentina and the Telescope Array in Utah detect the air showers created when ultra-high-energy cosmic rays hit Earth's atmosphere. These particles have energies millions of times greater than what our most powerful accelerators can achieve, yet we don't know what could accelerate them to such extremes. The GZK cutoff predicts that cosmic rays above a certain energy shouldn't be able to reach us from distant sources, as they would lose energy interacting with the cosmic microwave background. Yet we observe some particles that seem to violate this limit. Are these evidence of nearby sources we haven't identified, new physics we don't understand, or traces of events that have been deleted from other wavelengths? The data from all these observations, these different ways of listening to the universe, paint a remarkably consistent picture. The universe appears to follow mathematical laws, to evolve predictably from its initial conditions, to preserve information even when transforming it dramatically. Yet there are enough mysteries, enough unexplained observations, enough tensions between different measurements to suggest that our picture is incomplete. Perhaps what we're missing is an understanding of how the universe edits itself, how it might delete or hide information in ways our current theories don't predict and our current instruments can't detect. Scientists are developing new tools to probe these mysteries. The Vera Rubin Observatory will survey the entire visible sky every few nights, looking for transient events, things that appear or disappear, that change or move. If cosmic deletion events occur, even rarely, this comprehensive monitoring might catch them in action. The Nancy Grace Roman Space Telescope will map dark matter with unprecedented precision, perhaps revealing whether its invisibility is due to some form of cosmic deletion. The Laser Interferometer Space Antenna, LISA, will detect gravitational waves from merging supermassive black holes, possibly revealing what happens to information in these ultimate deletion events. Quantum computers might give us new ways to simulate cosmic processes, to explore what kinds of deletion mechanisms could exist without violating known physics. These computers, operating on quantum principles, might be better suited to understanding a universe that might itself be computing on quantum principles. They could help us explore whether information can truly be deleted or only scrambled, whether the universe's apparent delete button is real or an illusion created by our limited perspective. Machine learning algorithms are being trained on vast astronomical datasets, looking for patterns human scientists might miss. These artificial intelligences might detect subtle signs of cosmic editing, statistical anomalies that hint at deletion events, correlations that suggest reality has been altered in ways we haven't imagined. As our data collection capabilities expand exponentially, we need these computational tools to help us listen to what the universe is telling us, to hear signals in what might otherwise seem like noise. The multi-messenger astronomy era has begun, where we observe cosmic events through multiple channels simultaneously, electromagnetic radiation across all wavelengths, gravitational waves, neutrinos, and cosmic rays. When neutron stars collided in 2017, we observed the event in gravitational waves and across the electromagnetic spectrum, from gamma rays to radio waves. This comprehensive observation revealed details no single messenger could provide. If deletion events occur, multi-messenger observations might reveal them through inconsistencies, channels where information is present or absent in unexpected ways. As we continue to listen to the universe, to gather data from every possible source, we're building an increasingly detailed picture of cosmic history. Every photon we detect, every gravitational wave we measure, every neutrino we capture, adds another piece to the vast puzzle. So far, this picture shows a universe that appears continuous, unbroken, evolving according to discoverable laws. But the mysteries remain: the dark matter and dark energy, the tensions and anomalies, the questions our data raises but doesn't answer. Perhaps the universe's delete button, if it exists, operates in ways so subtle that our current observations can only hint at its presence. Perhaps it works in dimensions we can't directly observe, at scales too small or too large for our instruments, in aspects of reality our theories haven't yet imagined. Or perhaps the consistency of our observations is itself the message, that the universe doesn't delete but only transforms, that information is truly conserved, that the cosmic story, once written, cannot be erased. The data continues to stream in, terabytes every night from telescopes around the world and in space. Scientists continue to analyze, to look for patterns and anomalies, to test theories against observations. We're like detectives examining a crime scene the size of the observable universe, looking for evidence of something that might not even be a crime, might not even be possible. But we keep looking, keep listening, because that's what science does. It asks questions of nature and listens carefully to the answers, even when those answers are whispered in wavelengths we can barely detect. In mathematics, we're only beginning to understand. As you rest there, perhaps drifting deeper into relaxation, consider that you're surrounded by this cosmic data stream. Photons from distant galaxies are passing through your body right now. Gravitational waves from ancient black hole mergers are gently stretching and squeezing the space you occupy. Neutrinos from the sun, from supernova, from the Big Bang itself are flowing through you by the trillions every second. You're not separate from this cosmic information flow, but immersed in it, part of the universe's ongoing conversation with itself. The question of whether the universe has a delete button remains open, awaiting new data, new theories, new ways of observing and understanding. Science has not found definitive evidence for cosmic deletion, but neither has it ruled out the possibility. The universe keeps its secrets well, revealing them slowly, one observation at a time, one measurement at a time, one discovery at a time, and we keep listening, keep watching, keep wondering, because the question itself drives us forward, pushes us to develop better instruments, better theories, better ways of understanding our cosmic home. If the universe truly has a delete button, if reality can be edited and revised, what does that mean for the significance of our lives, our choices, our creations? As you lie there in the quiet darkness, breathing steadily, consider that you might be resting in a cosmos where nothing is permanent, where everything is subject to revision, where the delete button could theoretically erase any moment, any achievement, any work of art. Yet rather than making existence meaningless, this impermanence might be exactly what gives life its poignancy, its beauty, its profound significance. Like a musician who knows the song will end, we create meaning not despite transience but because of it. Think about a sand castle on a beach, built with careful attention, decorated with shells and seaweed, standing proudly for a few hours before the tide comes in. The builder knows from the beginning that the castle will not last, that waves will inevitably reclaim the sand, that all their effort will be undone. Yet they build anyway, finding joy in the creation itself, in the temporary transformation of formless sand into structured beauty. The approaching deletion, the certain erasure by the tide, doesn't diminish the meaning of the creation, but might actually enhance it. The castle is precious precisely because it won't last forever, beautiful because it exists in this moment even though it won't exist tomorrow. Art has always grappled with impermanence and change. The ancient Japanese concept of mono no aware, often translated as the pathos of things, celebrates the bittersweet awareness of the impermanence of all things. Cherry blossoms are cherished not despite their brief blooming, but because of it. Their beauty is intensified by the knowledge that in just days or weeks the petals will fall, the trees will return to green leaves, and we must wait another year for their return. This aesthetic philosophy suggests that transience doesn't diminish beauty but deepens it, that the possibility of deletion makes the present moment more precious, not less. Consider music, an art form that exists entirely in time, each note appearing and vanishing, deleted by the next note, yet creating meaning through this constant process of creation and erasure. A symphony might last an hour, but each individual moment of music lasts only as long as the sound waves take to fade. The beauty emerges not from permanence but from pattern, from the relationships between notes that exist and then cease to exist, from melodies that arise from silence and return to silence. If we could somehow freeze music, stop it from changing, preserve every note forever, it would cease to be music and become mere noise. The delete button is essential to the art form. Without the erasure of each moment by the next, there could be no melody, no rhythm, no musical meaning. Your own life is like a piece of music, a temporal artwork where each moment gives way to the next, where yesterday's experiences are deleted from immediate reality, even as they shape today's possibilities. You cannot return to your childhood, cannot relive your first love, cannot recapture moments of triumph or tragedy, except through the imperfect instrument of memory. Yet this inability to go back, this constant deletion of the past from the present, is what allows you to move forward, to grow, to become. If every moment of your life remained equally present and accessible, you would be paralyzed, unable to change, frozen in an eternal now that contained all your nows simultaneously. The visual arts have their own relationship with deletion and revision. A painter might work on a canvas for months, adding layers, painting over sections that don't work, sometimes destroying nearly finished paintings to start over. The final artwork contains within it all these deleted attempts, these painted over mistakes and experiments. Even if we can't see them directly, they influence the final composition, the texture, the subtle variations in colour where old paint shows through. The masterpiece exists not despite these deletions, but because of them, each erasure a step toward the final vision. Digital art makes deletion even more explicit. Every graphic designer, every digital artist knows the power of Ctrl+Z, the undo function that allows infinite experimentation without permanent consequences. They can try bold choices knowing they can delete them if they don't work, can explore creative territories they might not dare to enter if every mark was permanent. This freedom to delete paradoxically enables greater creativity, more willingness to take risks, more innovative final products. The delete button becomes not a tool of destruction, but of creation, enabling art that wouldn't exist without the possibility of erasure. Writers understand deletion intimately. The famous advice to kill your darlings acknowledges that good writing often requires deleting passages we love, but that don't serve the overall work. Every writer knows the pain of deleting a beautiful sentence that doesn't fit, a clever paragraph that disrupts the flow, sometimes entire chapters or characters that seemed essential but proved superfluous. The final book, the one, reader's experience is shaped as much by what was removed as by what remains. The negative space, the deleted words, are invisible but essential to the work's impact. Consider the oral traditions that preceded written language, stories passed down through generations, each telling slightly different, each narrator adding and subtracting details. These stories were constantly being edited, revised, updated for new audiences and new times. Yet rather than degrading the stories, this constant revision kept them alive, relevant, meaningful to each generation. The delete button of imperfect memory and creative retelling ensured that only the most powerful elements survived, that the stories evolved to maintain their impact across centuries. Even our written traditions, seemingly more permanent, are subject to deletion and revision. Ancient texts survive only in copies of copies, each transcription introducing small changes, intentional or accidental. Languages evolve, making old words unintelligible. Cultural contexts shift, changing meanings even when words remain the same. The Library of Alexandria, which we mentioned earlier, contained perhaps 400,000 scrolls, the accumulated knowledge of the ancient world. Its destruction, whether by fire, neglect, or gradual decline, deleted irreplaceable works of literature, science, and philosophy. Yet civilization continued, rebuilt its knowledge, created new libraries. The deletion was tragic but not terminal. It created space for new knowledge, different perspectives, fresh creations. Architecture embodies a particularly interesting relationship with deletion and permanence. Buildings are created to last, yet they're constantly being modified, renovated, eventually demolished. The ancient ship of Theseus paradox asks, if a ship's parts are gradually replaced until no original parts remain, is it still the same ship? The same question applies to buildings maintained over centuries, to cities constantly rebuilding themselves, to any structure that persists through change. Perhaps identity doesn't reside in permanent substance but in continuity of form, in patterns that persist even as their physical manifestation is deleted and renewed. The ruins that dot our landscape, from Roman aqueducts to abandoned factories, show us deletion in slow motion. These structures are being reclaimed by nature, their human purposes erased, their meanings transformed. Yet ruins have their own beauty, their own significance. They remind us that all our creations are temporary, that the delete button of time will eventually claim everything we build. Rather than despair at this inevitability, we might find it liberating. We build not for eternity, but for now, for the generations who will use our creations before they too are deleted and replaced. Photography presents a fascinating case study in meaning and deletion. Every photograph is a deletion of sorts, removing a moment from the flow of time, freezing it, preventing it from being completely erased by the passage of time. Yet photographs themselves fade, digital files corrupt, memories of what the images mean are lost. We take billions of photos now, far more than any previous generation, yet most will be deleted, lost in hard drive failures, forgotten in cloud storage, meaningless to future generations who won't recognize the faces or understand the contexts. Are we preserving more or less than our ancestors, who had only a few precious photographs, each one carefully preserved and remembered? Film and video create the illusion of preserving time itself, of defeating deletion by capturing motion and sound. Yet they too are subject to decay, to format obsolescence, to the loss of cultural context that makes them meaningful. Silent films from just a century ago can seem like transmissions from an alien world, their acting styles, their pacing, their assumptions so different from ours. The medium that seemed to promise permanence reveals itself as just another temporary form, subject to its own forms of deletion and decay. The internet promised permanent universal access to information, a defense against deletion. Yet links rot, websites disappear, platforms shut down. The average web page lasts less than 100 days before being changed or deleted. Social media posts that seem permanent can vanish when accounts are deleted or platforms change their policies. The digital age, rather than defeating deletion, has accelerated it, made it more pervasive, more unpredictable. We live in an era of constant creation and constant erasure, where viral content can reach millions in hours and be forgotten in days. But perhaps this acceleration of deletion is teaching us something important about meaning. If permanence doesn't guarantee significance, if deletion is inevitable regardless of the medium, then meaning must come from something else. Perhaps it comes from the experience itself, the moment of creation or appreciation, the temporary but real impact on consciousness. A song that moves you to tears doesn't become less meaningful when it ends. A sunset doesn't lose its beauty because night follows. A human life doesn't become pointless because it will end. The Buddhist sand mandalas offer a profound meditation on this relationship between creation, meaning, and deletion. Monks spend days or weeks creating intricate patterns with coloured sand, working with intense concentration and devotion. Then, in a ceremony, they deliberately destroy the mandala, sweeping the sand into a jar and often pouring it into running water. The deletion is not a negation of the creation, but its completion. The mandala's meaning doesn't reside in its permanent existence, but in the process of its creation and destruction, in the meditation it enabled, in the lesson it teaches about impermanence. Your own creative acts, whether artistic or everyday, participate in this same cycle. The meal you cook will be eaten and gone. The garden you tend will eventually return to wilderness. The children you raise will grow up and leave. The work you do will be superseded by others' work. Yet none of this deletion diminishes the meaning of your efforts. the meal nourished, the garden gave beauty, the children carry forward what you taught them, your work contributed to the ongoing human project. Meaning doesn't require permanence, it requires presence, intention, connection. If the universe has a delete button, it might not be a bug but a feature, not a flaw in the cosmic design but essential to its function. Without deletion, there could be no change, no growth, no evolution. The universe would be static, frozen, incapable of novelty or creativity. The delete button enables the universe to be a work in progress, constantly revising itself, exploring new possibilities, creating new forms of beauty and complexity. We are part of this creative process. Temporary patterns that arise persist for a while, then dissolve back into the cosmic flow, making room for new patterns to emerge. Consider evolution itself as a cosmic art project, life constantly experimenting with new forms, deleting those that don't work, elaborating on those that do. Every species that has ever existed is a creative attempt, a solution to the problem of survival and reproduction in a particular environment. The vast majority of these attempts have been deleted through extinction, yet their genetic innovations often persist in descendant species. Your own DNA contains successful experiments from billions of years of evolution, preserved information from countless deleted species that contributed to your existence. Human culture evolves through a similar process of creation and deletion. Languages arise, flourish, and die. Religions emerge, spread, and fade. Technologies are invented, adopted, and obsoleted. Each deletion makes room for new creation, each ending enables a new beginning. The cultures that seem most permanent to us, that have lasted millennia, have done so not through stasis but through constant adaptation, deleting outdated elements while preserving core values and practices. They survive through change, not despite it. Even scientific theories, our best attempts to understand reality, are subject to revision and deletion. Newtonian physics wasn't wrong, but it was incomplete, superseded by Einstein's relativity for extreme conditions. Einstein's theories might themselves be superseded by quantum gravity, or some theory we haven't imagined yet. Each scientific revolution deletes some of our previous understanding while preserving what remains valid. Science progresses through creative destruction, constantly deleting inadequate theories to make room for better ones. This view of meaning in an editable universe suggests that our purpose isn't to create permanent monuments to ourselves, but to participate fully in the ongoing creative process. We are not the authors of reality but characters in a story that's being written as it's being read, editors as well as readers, creating meaning through our choices and actions even if those choices and actions are ultimately temporary. The delete button doesn't erase meaning but enables it, creating the space for new meanings to emerge. Love might be the ultimate example of meaning that transcends deletion. The people we love will die, we will die. Eventually, even the memory of our love will be deleted from the universe. Yet love remains meaningful, perhaps the most meaningful thing we experience. It shapes us, changes us, connects us to something larger than ourselves. The temporary nature of human life makes love more precious, not less. We love knowing that loss is inevitable, that the delete button will eventually claim everything we cherish, and we love anyway. This might be the ultimate assertion of meaning in an editable universe, choosing to create, to connect, to care, even knowing it's all temporary. Art in all its forms might be humanity's way of wrestling with the cosmic delete button, acknowledging impermanence while asserting significance. Every artwork is a small rebellion against deletion, an attempt to preserve something of human experience, to communicate across time, to leave a trace that might outlast its creator. Yet the greatest art often acknowledges its own impermanence, incorporates transience into its meaning, finds beauty in the very fragility it's trying to transcend. As you rest there, perhaps feeling yourself beginning to drift towards sleep, you are yourself a work of art in an editable universe. Your consciousness creates meaning moment by moment, weaving experiences into memory, memory into identity, identity into connection with others and the world. This meaning doesn't depend on permanence. It doesn't require that your story be preserved forever in the cosmic archive. It emerges from the living of life itself, from the choices you make, the connections you form, the small creations and deletions that make up a human existence. Tomorrow you'll wake and continue this creative process, adding new experiences while allowing others to fade, building on what remains while letting go of what no longer serves. You'll press small delete buttons and small create buttons, participating in the universal process of revision and renewal. And in doing so, you'll be creating meaning not despite the universe's potential delete button, but in harmony with it, understanding that impermanence and significance are not opposites but partners in the dance of existence. The universe might be editable, reality might be revisable, the delete button might be real. But meaning persists, beauty endures in its temporary way, love continues to matter even when it ends. This might be the deepest truth about our cosmic situation. That meaning doesn't require permanence, that significance doesn't depend on being saved forever in some cosmic hard drive. Meaning emerges from the process itself, from the ongoing creation and deletion, from the constant change that allows new forms to emerge from old ones dissolving. In this view, the universe's delete button isn't something to fear, but something to embrace as part of what makes existence meaningful. Without it, we would be frozen in an eternal present, unable to grow or change or create anything new. With it, we are part of an ongoing cosmic improvisation, a jazz performance where notes appear and disappear, but the music continues, always fresh, always surprising, always meaningful in the moment of its creation.